Hello everyone, I'm audible. Okay, so fine guys. I think I'm audible. Good afternoon, everyone, and let's start with the class. Yeah. So just confirm me, guys, once I'm audible, loud and clear to all of you, and good afternoon. So yeah. So I believe in last class I was talking about a decision tree, right? So anyone who can tell me like what we have discussed in last class in terms of a mathematical concept and what is decision tree? So maybe just as a summary. So anyone who would like to talk about it, they can raise their hand and just in 2 minutes or 3 minutes. So you have to summarize. So anyone who would like to talk about it, please raise your hand. Yeah, go ahead, please. Yeah. Okay, yeah, Naveen, you can go ahead with your explanation.
Hello.
Yes, yeah, Naveen, you're audible.
So in the previous classes, we discussed about the decision tree and we learned about how the decision tree works. It works on basically two methods we have learned till now. That is the Gini entropy and one is the information gain.
Okay.
And in the Gini entropy, the basic formula that is used behind it is uh, P in the formula that is summation of I is equal to 0 to n minus 1, where n is the number of samples that are present, and P of I into 1 minus P of I. This P of I formula can be changed according to the situation. For binary classification problems, the formula basically becomes 2 into P of I into 1 minus P of I. So, and in the other cases, the information gain, we use the formula that is summation of I is equal to 0 to n minus 1 p of I into log of p of I, there where p of I is the probability of a set in the data set. So afterwards we learnt about how we can calculate this Gini impurity and the information gain to calculate which of the features we can implement it in the root node and which of the features will come inside the child node.
Fine. Yeah, that's a kind of explanation. Okay, so anyone else who would like to explain? So in 1 to 2 minutes.
Hi Sudhanshu, this is Anuj
Yeah,
here.
hi.
Please, yeah.
I'll like to go for decision tree. So, like it can be used, like firstly, what we discuss is it can be used with regression and classification tasks, and it is more powerful than both of the algorithms that we have studied. So we discussed about an example with class, gender, and staying in hostel. That example we discussed. So we could draw the decision tree with our hands, but the problems that we face is like who will be the parent node and who will be the child node. So that's why we have this Guineas in place. So Guineas formula is nothing like one minus a summation of p of I square, where I is the number of classes that we have, and then we calculated the number of Guineas for individual class and gender column, and then we found out like Guinea of gender is like greater than Guinea of class, which means like it has more impurities than the class column. So that's why we selected Guinea of class, and similarly we went down to the child node and we selected like a Guinea of gender. Then uh, we discussed about entropy and information gain. Entropy is nothing like scatterness, we can say, and information is the difference between a entropy before and after. So in that entropy formula, it's like minus p of probability of y log of py. So then we calculated like entropy for hostel and class column, and then we found out like with the information gain that higher than entropy, lower the information gain. In that we found out like in information gain for class is greater than information gain of gender. So that basically sums up like more the information gain, less the entropy and less impurity. So that's how we select a parent class, and similarly we select for the child classes.
Okay. Yeah. So that's it. Is yeah, that is something that we have discussed in our last class. So thank you so much. And I think many of you have like raised a hand. So I believe most of you are able to understand the concept that we have discussed, which is again a very important concept, right? So if I have to summarize this entire concept, so we had talked about two things. One is a information gain, and one is a like a I would say Gini indexing, right? So information gain we try to calculate based on before and after entropy. So what will happen? So over here is like we try to calculate a entropy, and then before, and then we try to calculate entropy. So after a creation of a decision tree, right? So after or you can say maybe a column wise, or I can say attribute wise. So we try to calculate a entropy that if I'm using this attribute, then what will be the information gain? And if I'll be using another attribute, then what will be the information gain? And based on that, so we will keep on dividing our data set. And in case of impurity or Guinea impurity, right? So again, we do the same thing, but yeah. So in case of a Guinea impurity, so we always try to select something which is having a less impurity. And in case of information gain, so we always try to select the attribute which is having a higher information gain. And again, so information gain will be calculated based out of entropy. This is the concept that we have discussed. Agree, everyone? Yes. Okay. And again, so tomorrow, just an announcement. So tomorrow is our last date of submission of your DVC task or ML flow task that we have assigned to you. And hopefully by Monday. So I think we have seen most of your tasks. And yes, so some of your task is under evaluation as of now. So as soon as this will be evaluated, and for sure it will be evaluated before a Monday, right? So from Monday onwards, we are going to start our discussions as well, right? So we will send you a link, and those who are interested to talk about your work with respect to any task that we have discussed or that we have taken in this particular lecture. It's not an assignment. So the task which I used to give you in my classes. So yes, those tasks you all can discuss and that will start. So I think I have already made announcements. So please make sure that send us your task before tomorrow. Those who have not sent, those who have sent, it's completely fine. So we are taking care of it, and we are talking about we are discussing about it like your task, and my team is trying to verify each and everything, that what you have done, how you have done, and many more things. Yeah. So fine, guys, let's start with the decision tree. I think the decision tree topic is pending. And today we will try to discuss and we will try to understand that how this kind of a things works with respect to a regression or with respect to a classification. So with respect to classification, we have discussed that if your attributes are a categorical attribute and your labels, right? So if your features are categorical, if your labels are categorical, so yes, in that case, with the help of Gini or with the help of information gain, I will be able to create a tree and I will be able to make a prediction that, okay, so this particular data set belongs to what classes, right? So if on a broader label, right, if I have to separate, or maybe if I have to segregate your like a complete discussion, right? Or maybe if I have to classify a complete problem, so I can try to classify a complete problem in this way. So maybe a problem number one can be, so input variable or maybe a feature, right? Feature is categorical and your outcome is categorical. There can be a second case, so where feature can be continuous, outcome can be a categorical. There can be a third case, feature can be continuous, and outcome will be continuous, right? So can I make a statement over here that if your feature is categorical and if your outcome is categorical, right? So in that case, we are trying to solve actually a classification problem. If your feature is continuous and your outcome is categorical, so even in that case, we are trying to solve a classification problem. And your feature is continuous. Continuous means maybe some number, some real number you have, right? And your outcome is also a real number or continuous number. In that case, can I make a claim that we are trying to solve a regression problem? So is this understanding clear to every one of us? Yes. So these are the three possibilities that you will be able to find out. So let's suppose I have given you a data set. Now in that data set, I have given you X, I have given you Y. Now, so in my X data set or in my feature variable, right, or my feature attribute, I have a categorical data set. So last time, I think we have taken those kind of a data set, right? And again, in terms of outcome, so I'm looking for some sort of a categorical variable. So for sure, if outcome wise, if I'm looking for a categorical variable, by default, it will fall under classification. Second case can be, I have a continuous data set. So let's suppose I have a reading of a different temperature, or maybe a weather condition, a rainy condition, humidity condition. And based on that, so I'm supposed to decide in such a way that, okay, so today it is going to be a rainy, or today it is going to be a sunny, or today it is going to be maybe a winter or something like that, if we have to classify. So again, our continuous variable is a feature, that is completely fine, but our labels are categorical, and that problem statement will again fall under classification. So you will have to apply a classification over there. Now there can be a third situation, so where my feature is a real number, or it's a continuous data set, and even my labels, right, even my labels are a continuous data set, continuous records which is given to me. So in that case, for sure, we are trying to solve what? So we are trying to solve a regression problem, so where we are supposed to predict a real number or maybe a continuous number. And yes, a decision tree can solve all of these three problems. But inside a decision tree, again, you will be able to find out a different algorithm. Base concept is not going anywhere. So whatever base concept that we have discussed, for example, we talked about a Guinea, we talked about information gain. Inside information gain, so we had entropy, because changes of information gain, or maybe like a difference between information gain before and after is difference between before and after entropy is called as information gain. So yes, these are the base concept, and based on that same base concept, so there are a different classification, or there are different algorithms inside a decision tree you all will be able to find out. So let's try to understand first of all, so what different kind of situations, or a different kind of algorithm you all will be able to find out. And from interview perspective, this is again very important. So there is something called as inside decision tree, based on the same concept. So there is something called as ID3 algorithm. There is something called as C4.5 algorithm. There is something called as CART algorithm, CART algorithm. So these are the different algorithms you will be able to find out inside or within a decision tree. And based on the problem statement, based on the data set, so we can try to use a different algorithm. We have an option. So whenever we'll do an implementation, you can see that yes, we have an option as a parameter where we can select IG3, we can select C4.5, we can select a CART algorithm, CART. So it's not CHAD. Okay, CHAD is also an algorithm for sure. All right, so CHAD is also one of the algorithm, but yeah, these are the popular algorithm you will be able to find out inside a decision tree. Now, if I'll talk about ID3, so full form of ID3 is iterative dictomizer. So this is a full form of ID3, iterative dictomizer. So iterative dictomizer again is been used for a classification problem statement. So let's suppose if I'm trying to solve a classification problem, in that case, yes, I can try to use ID3 as a base algorithm, and it will try to work on a categorical attribute. So if I have a categorical attribute, I can try to use a ID3 or iterative dictomizer which will be able to solve my problem based on the same funda that we have discussed, same concept that we have discussed. The second number algorithm is called as C4.5. Again, you can say that it's kind of a like a revision of ID3 algorithm, but the way it tried to divide a data set is a little bit different. Based on the criteria, it will try to divide a data set, it will try to divide a node, it will try to decide which one is going to be a parent node, which one is going to be a child node, is a little bit different, but just an improvisation of ID3 algorithm, you will be able to find out. And again, this C4.5 has been used for a classification task. CART, if I'll talk about CART, so CART is nothing but classification and regression algorithm. This is a full form of a CART, classification and regression tree. So this full form you will be able to find out, and as its full form suggests, right? So this CART algorithm can be used for regression as well as for a classification. So everywhere, right, whenever we are trying to create a decision tree, it is using a similar kind of a concept. Now you will ask me a question that, okay, so in case of a continuous data set, in that case, how it is going to decide, or maybe how it is going to create a decision tree, right? So let's try to understand that particular part. And then you will be able to understand what happens inside a card, what happens inside C4.5, what happens inside ID3 in an easiest possible way. So first of all, I will be talking about a classification and regression tree, this CART, so CART algorithm, right? So let's try to understand this particular part, right? So how this CART algorithm works, and then maybe we can try to understand so how this CART algorithm can be used, right? So how this CART algorithm can be used for a different purposes to solve your regression and a classification task. So here, let's suppose if I'm talking about maybe a kind of a data set. So maybe I can consider some dummy data set over here. In this data set, we have X1 column, we have X2 column, we have X3 column, and we have Y column. Fine. And I'm going to take this particular case maybe as of now, right? So we have a continuous feature and we have categorical outcome. So here, continuous feature wise, so I have like 1.1, 2.2, so 3, 3.6, 5, 5.8, and 8. Inside X2, so I have maybe 7.5, 8.8, 9.2. So again, this is just a cooked up data set. So I'm just trying to create it now. 5.1, 5.4, 2, and 1. Now, so here we have, let's suppose 2.5, 5.5, 6, 6.7, 7, 8.9, 9.1. And here, so we have two features, let's suppose, two labels. So A, B, A, A, B, B, A. So we have a continuous data set. So I'm talking about a second instance, second case, because this case I think we have already discussed right in our previous classes. So if I'm considering this particular case, so here our feature is a continuous data set and our outcome is a categorical data set, AB, AB, AB kind of a thing. So maybe it's a binary class or maybe it's a multi-class classification that we are trying to perform. That's completely fine. Now here in this case, how it is going to create a tree, because a concept of tree is we are supposed to select a node. If we are not supposed to select a node, that who is going to be a parent node, whether it's going to be a X1, whether it's going to be a X2, whether it's going to be a X3. If it is X1, then again, how separation will happen. So what sort of a data set will go on right hand side? What sort of a data set will go on left hand side? It is going to create a 2 branches, 3 branches, 5 branches, or 8 branches. So we are supposed to make that kind of a decision. And then only I will keep on like doing this kind of a separations. And then finally, I will be able to build a decision tree. So here, a concept is that it will try to create a threshold. So let's suppose if for x1 column, so what is the average? What is the average of x1 column? Anyone who can tell me? So manually, maybe we can try to solve it. So what is the threshold for x1? Sorry, what is the average of x1? So yeah, 4.1 or approximately 4 is going to be an average, right? So 4 is going to be an average, or maybe we can try to use some different method as well to create a threshold. So let's suppose 4.1 is an average and 4 is a threshold. I'm trying to assume. Again, this is my assumption. This is my hypothesis that I'm trying to create. So if 4 is going to be my assumptions or 4 is going to be my threshold, so can I say that any data set which is available over here, so we can try to create a two categories. So maybe a data set which is having a values lesser than 4 and a value greater than 4. So can I say that we can try to divide a data set which can have a values greater than 4 and a lesser than 4. Agree, everyone? Yes. So let's suppose 4 is my threshold, and again 4 is my assumption that based on the average, so I'm trying to create a threshold. Now, what is an average of column x2 and what is an average for column x3? So let's suppose average for column x2 is 5. So maybe based on this 5, so we can try to divide. So greater than 5 and lesser than 5. And what is average of x3? So let's suppose average of x3 is approximately 6, or maybe somewhat like 6 or 5, right? So let's suppose if I'm trying to create a threshold greater than 6 and a lesser than 6 over here. Now, can I say that all of these respective columns I will be able to divide based on this criteria? So lesser than greater than 4, lesser than greater than 5, lesser than greater than 6. So based on that, the entire data set available inside this column will be divided. Or this is one of the approach. Or there is a possibility that we can try to create a multiple threshold. So average is 4, half of 4 is 2. So a data set which is having a value lesser than 2, in between 2 to 4, 4 to 6, and then 6 to 8. So can I say that we can try to create even a 4 categories out of it? Yes. So if I'm trying to take a threshold or maybe a range of 2, right? So lesser than 2, in between 2 to 4, 4 to 6, and more than 6, or 6 to like infinity. So can I say that even in that way, I will be able to create a 6 different bins, or maybe I will be able to create a 6 different division with respect to this data set. Agree? Yes, everyone? Okay. So if we are able to do that, right? If we are able to perform these kind of operations, so can I say that I will be able to create a Gini, or maybe I can calculate even an information gain? So Gini is what? So we have calculated a Gini based on the probability criteria, right? So 1 minus P of square, Pi square. This is what we have discussed. And based on that, so we were trying to calculate a Gini over here. So now if I'll ask you, so can you please calculate a Gini for this 2 category or maybe for a 4 category? Because you just have to find out that what is the probability that your data set will belongs to this category or that category in a single attribute or in a single feature column itself. So can we do that? Just by using a same concept, the concept that we have discussed in our previous classes. Yes or no? And in the similar way, right? So yes, people are saying yes over here. So, and in the similar way, so can we say that we can try to calculate even entropy? So entropy, in case of entropy, what we do? So we try to calculate the entropy of the final outcome. So which is nothing but y. So yes, it's a categorical variable. So we will be able to calculate the entropy of y. That is completely fine. Apart from that, what we can do is, so maybe we can try to calculate the entropy after a division. So even column wise, so we are trying to create a categories. We are trying to create a threshold. And based on that, so we are trying to create a separation. So even entropy is possible, and we all will be able to calculate a entropy. So when we have a continuous data set, so we try to create a exact similar kind of a situations that we had with respect to a categorical data set. And based on that, again, we try to calculate an information gain. Again, we try to calculate a Gini. and we can try to divide our data set, because the whole purpose is to divide a data set in such a way that I will be able to build a tree. For example, so in a very first case, so when I was trying to find out the information gain, so I found out that, okay, information gain for x1 column is high, and here threshold is 4. So now can I say that if x1 is a column, and this is going to be a parent one, whatever data set we have which is having a value more than like a lesser than 4, right, will go on this side, and whatever values we have greater than 4 will go on this side. Based on that, if I'll try to create a separation, so can I say that I will end up separating this data set into a two state? So this is one of the data set, and this is one of the data set. Is it fine? Yes. Okay. So Akshat is saying that, are we converting a data set numerical variable into a categorical variable? Right? No. We are creating a threshold. We are not converting any data set. So what we are trying to do is, we are trying to create a range, right? A bins, you can say. So we are trying to create that range. We are trying to create that bins, and that bins, a complete data set inside that bins, we are trying to treat that as a categorical, one of the categorical. So idea wise, yes, it's the same thing that we are trying to do, that we have already done in our previous cases with respect to the categorical data set. But data wise, we are not making any kind of a changes. What we are doing is just lesser than 4, greater than 4. Fine. Now divide the data set. So now if I have to divide the data set, who is going to be a second node, or who is going to be the child node over here? So maybe I have to make a decision out of x2 and x3, that who is going to be a child node. Even x1 can participate, depends upon the data set. If I'm not able to do a clear separations over here, so even x1 can participate. But let's suppose we have done for x1. So now I'll not even look into the x1 part. What I will do is I'll try to look into my x2 part and my x3 part. Yes. Now out of x2 and x3, so when I was trying to calculate the information gain, I found out that, okay, so for x1, so for x2 and x3, so this time x2 is giving me more information gain. Again, we have a threshold, 5 is a threshold for x2 and 6 is a threshold for x3. So again, we will start dividing a data set lesser than 5. So let's suppose on this label, so we have these data set, and on other side, so we have these data set, right? So we can try to decide, or we can try to divide a data set, that, okay, so here x2, and there is also a chance that in this side we can have x3 as a parent node. It's not like in this, because now we have a two separate table or two separate data set out of the original data set. So there is a possibility that on this side my parent node will be a different column, and on other side, so parent node will be a different column. And again, I'm not saying that it's a binary tree I'm trying to create. No, your branches can be 3, 4, 5, 6, 8, depends upon a number of threshold you will end up creating by using some specific algorithm, right? So here, if I'll try to say, or if I'll try to understand, so here maybe let's suppose on my left hand side, so I have a x2, and on my right hand side, so we have a x3. Now here I can try to create a separation. So x2 lesser than 5, and on this side, so x2 greater than 5, and x3, so what is the threshold for x3? So maybe lesser than 6 over here on this side, and greater than 6 on this particular side. And then we can start again dividing our data set. So inside x2 column, right, a first data set, I believe, so we don't have any values which is having a value lesser than 5, right? All the data set will come on this particular side. Again, if I'll talk about x3, so x3 and then lesser than 6. So yes, we do have some values which is having a lesser than 6, right? And we do have some values which is having a values greater than 6. So again, we will start creating a subset of the data set on this side and this side. So for every threshold, we will start separating a data. And in this way, we will keep on making this kind of a division unless and until we are not able to reach out to a point where further separations is not possible, or further division is not possible. And then that will represent our final classes, or we can say it's called as leaf node. So this is all this is something that we always do in case number 2, where we have a continuous feature and where we have a outcome wise, we have a categorical outcome. This is something that we always try to perform in case of a classification example. And finally, yes, I will be able to get a result, or I will be able to get a data, or probability I will be able to see. Now let's suppose I have case number 3, right? So where our feature is continuous as well as our outcome is continuous. So this is a pure regression problem. And in case of a regression problem, so what we can do is, or how CART will be able to solve this particular regression problem, let's try to understand. And this will give you a very clear understanding and idea that yes, this is how CART is going to work, and this is how CART is going to make a separations, or maybe it is going to give me a prediction with respect to a regression example. Again, inside that, so there is something called as a regression approach, and based on your y and y hat square method, and there is something called as a greedy approach. Based on that, we try to create a tree. So there are algorithm inside the algorithm inside the algorithm. So 2 or 3 level of algorithms you will be able to find out inside a decision tree itself. So let's suppose if I'm trying to work on a use cases where I have all the x values, which is a continuous value, x1, x2, x3, and y. So we are trying to give 1 to 1, and maybe outcome is equal to 3. Then 2.4, 5.8, and 6, outcome is equal to 10. 2.9, 6.1, 7.2, outcome is 12.8. Input is maybe 5.8, 2.8, 9.6. Outcome is 13.9. 7.2, 7.8, 8.9. Outcome is equal to 14.8. So can I say that this falls under a regression problem? Yes, everyone. So this is nothing but it's a regression problem. So we are trying to send a continuous data, and we are expecting a continuous data as an outcome or as a y values. In this case, how your card is going to solve your problem, or how it is going to find out a value of y. So let's try to understand this particular part. So CART always follows a specific method for solving a regression problem. And let's try to understand that particular method. So again, here we are trying to create a decision tree. So we have to create a split. Unless and until we are not creating a split, again, it's of no like this, it is not going to make any kind of a sense that we are working on a decision tree. So tree, at the end of the day, we all have to create. But how we are supposed to create these tree, so that is a little bit different, and you can say it's a little bit tricky that you will be able to find out. So here what it does is that it will try to take your column number x1, x2, and it will try to take column y, column x1, x2, x3, and it will try to consider y. And then it will try to do a certain calculation. So it will try to find out, or it will try to understand that if we are dividing our data set based on our respective threshold, then what will be our final values of y hat that we are able to receive, and how our y hat is different from the expected y that we have. So let's try to understand maybe in this way. So let's suppose based on a threshold, so the same old concept from point number 2. So we are trying to create a decision tree. So we have created a threshold greater than lesser than 2, maybe over here greater than lesser than 5, maybe over here, so greater than lesser than 6. So based on that, so we have divided our entire data set. We are trying to divide our entire threshold, and we are trying to create a tree. So here we have x1, and on this side, so we have x2, on this side we have x3, let's suppose, and then finally So we are trying to make a certain calculation. So let's suppose this is going to give me 5 maybe, and this is going to give me 10. It's a very simple separations that we have done. So here, maybe based on 2, it is trying to divide. Here, based on 5, it is trying to divide. And here, so based on 6 as a threshold, it is trying to divide. Greater than, lesser than. Right? Now, what will happen? So this tree is constructed. This tree is created. Now, how I will be able to get a continuous output? That's a question. And how it will be able to structure a complete data set. So here, a formula is, so we always, based on the best split, we try to calculate that what will be a summation of y minus y hat square on one side plus summation of y minus y hat square on other side. So let's suppose I have this side and I have this side, and all of this decision tree or branches are trying to participate in terms of finding out a final result or calculating a final values, which is required for prediction. So here, what it will do is, so it will try to first of all create a threshold. Now, once I have created a threshold, let's suppose in my parent node, so I have a threshold is equal to 2. So whatever data set which will be having a values lesser than, so 2, based on column number x1, column name x1, so it will try to come in a left hand side. And whatever data set we have which is having a values more than 2, it will try to come on right hand side. So it will try to and then again, so we'll keep on doing up separations, and finally I can see one of the values. So whatever values that we are able to receive, or whatever average values that we are able to receive, so based on that, it will try to check. Okay, so let's suppose I was expecting, so here lesser than 2 and this and this. So I was expecting maybe a 7, and I have received what? I have received 5. Here I was expecting maybe a 12. I have received 10. Let's suppose. So if I have received 7, I was expecting 5. If I have received 12 and I was expecting 10, right? For all the values, that's the reason. So we have given summation of all the predictions that we are trying to do. So each and every data set. So here we have 1, 2, 1. We are expecting 3. So we'll try to check. So yes, expectation wise 3, what is an outcome I am able to receive from this particular tree? Again, 2.4, 5.86. Expectation was 10, and then we have received something else. So it will try to calculate a summation of both hand side, and then it will try to check what is a total residual or total loss or total error that we have received, and based on that, it will try to do some sort of a rearrangement of a decision tree, and then it will try to construct a decision tree at any point of a time. So here, right? So here, when we are talking about this y hat, y is fine. We are able to calculate it. But what is y hat, and how we are trying to calculate a y hat for each and everything? So y hat for each and everything, or prediction for each and everything, will be calculated based on the average of all the outcome that we are going to receive. Now, average of what outcome? So here we have 1, 2, 1. So here we have 1, 2, 1. So fine. So 1, 2, 1 means lesser than 2. It will fall under this criteria based on column number x1. Now again, so lesser than 5. It will not. So lesser than 5, it will fall under maybe this side. It will try to come lesser than 2. And again, let's suppose if I have a x3 over here, so again it will fall on this side. So now it is able to reach out to this point, and it is giving me outcome is equal to 3 in general. Now again, I'll try to check with the second one. That okay, fine. So 2.4, 5.86. So in which criteria it is trying to fall? Now it will try to take an average of this entire one attribute, or maybe one single record is giving you 3, but it will try to check the entire average. So maybe on this side, I have this data set. So I have this particular data set, I have this particular data set, and this particular data set. So it will try to check with the average of each and everything, and that is going to be the final outcome. Means that is going to be a final prediction for a y. It will try to give it to you, and then it will try to check. So how my y is different from my y hat? and that is something called as residual. So same concept that we have discussed in case of a linear regression. So we try to check what is the summation of all the difference between y and y hat. Same funda will be applicable over here in terms of checking a residual, but y hat will always be a average, and based on that it will keep on shifting a threshold. So this is how a CART algorithm works internally. So maybe we can try to take one neat and clean data set, and then we can try to design a complete decision tree, and then we can try to solve that particular problem. So let's try to consider one small, neat and clean data set without any kind of a complexity, so that we can make a division. So here I'll take this time only two columns, x1 and x2, and this is a outcome. Now, so I have 1, 2, 3, 4, 5, 6, 10, 20, 30, 40, 50, 60. Again, it's a very simple, straightforward data set. And then outcome wise, so 5, 10, 15, 20, 25, and 30. So this is the data set which is given to me. So now how I will try to create a decision tree. So I'll try to create, let's suppose, a threshold. So threshold will be this one I have created. So it's very easy to separate based on this threshold. So for column number x1, so it's 3 is a threshold. For column x2, 30 is a threshold. So fine, if I'm trying to calculate maybe information gain, so information gain for x1 is high. So let's suppose x1 will take a lead. So x1 will become decision, or x1 will become a root of the decision tree or planet node of the decision tree as of now. And here I'm trying to say that, okay, so 3 is a threshold or 3 is a criteria. Now, whatever data set we have which is lesser than 3, so it will fall in this region, and whatever data set that we have which is greater than 3, so it will fall on this particular region. So this table, let me pick a different color over here. So this table, right? So this table will come on this side, and this is a separate table or separate data set which will come on this side. Now here, so lesser than 3, and there is a possibility, there is a chances that maybe again I'll try to make a division based on x1 column itself. Depends, right? But here, so we'll not try to make this problem statement very, very complex. So we can try to make it very, very simple, right? So let's suppose I'm trying to divide this data set next time with x2 column. I can divide this data set again with the help of x1 column. There is no issue, but I have not used x2. So let's try to use x2 in our theoretical lecture. So here I'm trying to make a threshold based on 10. So less than equal to 10 and then greater than 10. So fine, I will be able to divide a data set in two categories again. So one will come on left hand side and other will be able to come on right hand side. So this is going to come on right hand side. Fine. Now again here, so we can try to divide a data set based on x2. And here, let's suppose I'm trying to create a threshold is equal to 50. So lesser than equal to 50 and then greater than 50. So fine, these two records will come on this side and these two records will come on this side. Let's try to keep this record as it is. So here, 1, 10, and 5. And on this side, so based on threshold of 10, so on this side, we have two records, 2, 20, and 10, 3, 30, and 15. And for this branch, we have 4, 40, and 20, 5, 50, and 25. On this side, I have 6, 60, and 30. Now, so let's try to calculate what is y and what is y hat. So I think we all are aware about y part. Agree, everyone? So we all have a y part, right? Yeah. So fine. We all are aware about a y part. This is the division. This is the basic separation that I have done. It's completely fine. Whatever is the separation. So we are not supposed to worry about it. So what we are supposed to understand over here is, so whether we are able to construct a right decision tree or not. If not, then what is a modifications I'm supposed to do, or maybe what is a further separations I'm supposed to do. So in my last slide, I told you that we try to calculate, right? So we try to calculate a residual based out of the y and y hat differences, and we always try to keep this residual as low or as minimum as possible, because in case of a regression, so that is something that we are supposed to achieve. So if residuals are minimum, in that case you are able to generalize your data set in a best possible way. Now let's suppose if I'm trying to calculate, right? So if I'm trying to calculate or if I'm trying to do a prediction for maybe my very first record, where x1 is equal to 1 and x2 is equal to 10. So x1 is equal to 1. So can I say that it will go on this side? X1 is equal to 1, right? X1 is equal to 1 will go on this side. Now x2 is equal to 10. So can I say that x2 is equal to 10 will come on this particular side? Yes or no? Yes, everyone, right? So what is my y, which I was expecting? So I was expecting y is, so I was like, my y is equal to 5. And can I say that this record is giving me 5 over here? So difference between y and y hat is equal to what? 0, right? But let's try to calculate a same thing for record number 2. Now, what I will do over here. So record number 2, x1 is equal to 2. So fine. Again, it will come this side. x2 is equal to 20. So can I say it will come on this side? Now, what will be y hat, by the way? What will be y hat? So can I say that my y hat, so people are telling me that y hat is equal to 10, and some of you told me that it's an average and it's going to be 12.5. I told you very clearly y hat will be calculated based on the average. This is the reason a previous case and this case is different, right? So it will be an average of what? Whatever record that we have. So we have created a table, right? We have now separated a data set. Now we are able to reach out to a leaf node. It's not a classification problem that we are trying to solve, where in a leaf side, so we'll be having a direct classes. No, we are not trying to solve that classification problem. We are trying to solve what? A regression problem. So let's suppose I have separated my data set. Now I'm able to reach out to this particular point. Here we have 2 records, right? So what will be, again, based on the separations, we are able to get 2 records over here. It's not like we have whole records in this particular place. So now what will be a prediction? So can I say that prediction will be 10 plus 15 divided by 2, which is nothing but an average of this side? Yes. So what was my y? So can I say that I was expecting 10, right? And I have received what? I have received 12.5. Agree or disagree? So y hat will be an average of all the record which is available in that particular branches, which is trying to participate for separating my data set. Yes. So my y hat will be 12.5. So can I say that we have certain residuals over here? Yes. Okay. Someone is saying that how we can expect 10. You can explain that. See, 10 we are expecting because it's a part of our original data set, right? So y is nothing but y is a part of my original data set. I'm trying to do supervised learning. So in case of a supervised, 10 is given to me. I'm trying to construct a decision tree. I'm trying to construct a refined decision tree where a residual will be minimum. It is supposed to separate a data set in such a way. So I have separated a data set, right? But I'm trying to test now that, okay, fine. So what is the total residual which I'm able to receive over here, right? Okay. So this is like a y and y hat. Now, if I'll talk about this data set, so can I say that even for this data set, our y hat is going to be 12.5? Yes. So it is going to be 12.5. Now for this data set, if this is the input that I have, so can I say that like outcome is going to be 22.5, right? Even for this one, 22.5. And for this one, it's going to be 30. So now how I will be able to calculate a total residual? So total residual is nothing but summation of y minus y hat of a square for all the instances, right? So this is my total residual. So residual for this branch is equal to 0. The residual for this branch is equal to 10 minus 12.5 of a square. So 2.5 of a square over here, 2.5 of a square over here, plus like let's suppose I am testing with one of the data set, right? Just with one. And residual for this data set is again 2.5 square. For whole data set, we can try to calculate. So even for this one, 2.5, even for this one. So it's nothing but 2.5 of a square plus 2.5 of a square, right? Plus 0. So can I say that for all the data set 1, 2, 3, 4, 5, 6, I believe we had 6 data set, right? So this is a total summation of residual that we are able to calculate. Yes. So total summation of residual. So anyone who can tell me number, residual in terms of numbers, anyone who can do this calculation, all the calculation, and then send it to me. So 25. People are saying that it's a 25. So fine, I'll go after this number. So total residual is equal to 25 over here. Total residual is equal to 25. Fine. This is one of the decision tree that we have created. Now I will try to create another decision tree, right? Based on the same data, whatever data set that we have taken. So based on the same data, so I'll try to create a decision tree. So maybe we can create a decision tree over here itself. So I'll try to take maybe x2 as a parent node. This time, so last time I have taken a threshold is equal to maybe something else. So this time I can try to take a threshold is equal to 2040. So yeah. So maybe I can try to take a 20 over here, and then I can try to take 40 over here, and then 60 over here, right? Okay. So 40 inclusive of 40 inclusive of 20 inclusive of 60. Understand in this way. We have a very small data set, right? So here, now, so if I'll start separating my data set, so can I say that these two data set will come on this side? Yes. So these two data set will come on this side, and these two data set will come on middle, and three data set will be on in middle, and then one data set will be available in a extreme right. So okay, I can start managing my data set. So maybe 6, then 60, and then we have 30 over here. If I'll talk about this middle one, so in that case we have 3 data set. So the space is very limited over here. So 330, 50. 330 and 15. And then 4, 40 and 20. And then 5, 50 and 25. Now on this side, inclusive of 20, and my parent is x2. 1, 10, and 5. 2, 20, and 10. Okay. So this is a data separations that we are able to do. And let's suppose this is a decision tree that I have created. I'm not dividing this tree further. Let's suppose that's a case. I'm not making any kind of a division, although I can make it based on x1. So again, I'm trying to show you over here that it's not like every column is supposed to participate in terms of making a separations of the data set. So you can ask me a question that, okay, you have just used x2, but you have not used x1 for doing a separations. It's completely fine, right? So I just have to do a best separations of the data set. It's not like every column is supposed to participate, every features or every attributes are supposed to participate, right? So here, what we can do is, so based on x2 values, I'm trying to like separate the data set, Deepak, over here, and Vinod sir, yeah. So I'm just trying to like separate the data set inclusive of this one. So lesser than, greater than, so lesser than 20 will come over here, lesser than 40, or okay, so I can say lesser than 50. 50 is a actual threshold, and again, so lesser than equal to 6, sorry, equal to 60 will come over here. So just try to imagine like this is the separation which I have created. Now if someone will ask me that, okay, or maybe I can try to further like divide this data set. So here I can consider x1 is equal to greater than 2. So everything will come on this side. So same data set I can try to replicate on this side. Exact same data set will be replicated on this side. So here, based on maybe x1 separation, and here if I'm trying to make a separation on x1, so I can try to divide my data set maybe based on this criterion. So half of the data set will go over here, 3, 30, and then y is equal to 50. Then on this side, based on x1, I'm trying to make a division. So it's a 4, 40, and 20, 5, 50, and 25. Now I'll start testing my data set. So 1, 0, right? So if I have 1, 0, so sorry, x1 is equal to 1 and x2 is equal to 10. In that case, what will be the values I will be able to get? So what will be the y hat? Yes. So can I say that in case of 1, 0 as an input, right? So y hat is nothing but it will be an average of these two, right? So 5 plus 10 divided by 2. And what is my y? So can I say that my y or expected y was 5? So what is a residual? So I'll just start like writing it down over here. So 2.5 square is a residual, y minus y hat. Again, for a second data set, so can I say that residual will be 2. So residual will be 2.5 square over here. Now my third data set, 3, 30, and 15. So what will my y hat? Can I say that y hat is going to be 15 itself? So what is your residual? So can I say that my residual is going to be 0, right? Okay, my residual is going to be 0 in that particular case. Now let's suppose if I'm talking about a fourth data set, 440 and 20. So what will my residual? So residual is going to be again 2.5 square. Now if I'm talking about a fifth data set, 550 and 25, so my residual is going to be 2.5 square. Now for my very last data set, my residual is going to be 0. So again, if you will try to do a summation, so what is your residual? So your residual is equal to 25. The same residual values you will be able to find out. Let's suppose I'm going to make a further separations of this data set, right? So there is a chances that I will be able to divide this data set into again 2 chunks, right? So there is a one chunk over here and another chunk of the data set will come on this side. So this is one chunk and this is the another chunk. So can I say that in this way, so residual will be 2.5 square plus 2.5 square? Yes. In that case, so my residual will be 2.5 square plus 2.5 square. So in third case, this is the third situation I'm talking about. So in situation number 1 over here, so in situation number 1, this is a situation number 1 that we are able to create. And here, so this is a situation number 2 that we are able to create. And let's suppose if I'm trying to divide my data set further, so in that case, maybe I'll end up creating a third situation. So there is a chances. I think there is some problem with my notebook. Yeah. So in the third situation, so let's suppose if I'm trying to divide my data set further, so this is the situation number 3. So in this case, I will be able to receive just a residual of 2.5 square plus 2.5 square. So now, which situation is a favorable situation for me? Situation number 1, 2, or 3. So if I'll give you an option that, okay, fine, so which tree you will try to choose, or by using which decision tree, so you will be able to separate a data and then you will finalize a decision tree. So which situation you are going to opt for? So you all are going to opt for a situation so where we have a minimum residual. Agree, everyone? Yes. So can I say that when we are trying to separate this data set, we are using a threshold. Now, when we are saying that we are using a threshold, so same concept of Gini and information gain will be applicable over here. Agree till this point? Right? In case of a regression, so what I will do is, so I will try to take an average. So whatever data separations that we have done till a very last layer, so whenever we are trying to make a prediction, so we will try to take a average, and then we will say that, okay, so this average or this structure is giving me a less residual values, so I will be opting for this one. Otherwise, I will try to make certain changes. Again, I'll try to separate it further, and then again I will try to test at the time of training. So I'm just talking about a training time, or at the time of training. So this is what I will try to do. Now at the time of testing, so let's suppose I have given you some unknown data set, some very new data set. So let's suppose I have maybe a situation over here. So 5 and maybe 40. So this is the input which I have given to you. So according to a tree number 1, this is, let's suppose, tree number 1. So according to tree number 1, what will be an outcome you all will be able to receive? Let's suppose this is the structure I have finalized. And your x1 is equal to 5 and x2 is equal to 40. What is the outcome? Yes. So can I say that x1 is equal to 5? So I will fall in this region. Yes, x1 is equal to 5. So based on x1, so it is trying to do a first separation. This is the root. So this will fall over here. Now, so then x2 is equal to 40, which will fall on this side. Now on this side, what in all data set we have, and what is the y? So can I say that it will give me 20 plus 25 divided by 2, which is equal to 22.5. So this is the outcome which I will be able to receive. Let's suppose I'm talking about situation number 2, a tree number 2, without considering these final separations. So this is our tree number 2. Now what will be an outcome? So our x1 is 5, x2 is equal to 40. Yes. So can I say that x2 is equal to 40? So first division we are trying to make over here based on the x2. So it will fall here in the middle one, right? It will fall over here. And now x1 is equal to 5, right? So x1 is equal to 5. So maybe it will fall over here. So 20 plus 25, and that is going to be my answer. Now, if I'll talk about a third situation, a third condition, right? So in that case, can I say my outcome will be 25? If I'm trying to divide this data set further, so can I say that I will be able to get a final answer or final outcome is equal to 25, right? So this is how things works in a regression side. So we always try to look after the regression like a residual whenever we are trying to construct a decision tree, and then based on that, based on the average value of all the participants, we are trying to give you the final answer. And this is something called as, or this is this is something that you will be able to find out in case of CART. So classification and regression tree for a regression purpose. For a classification purpose, I believe we have already discussed about it with respect to a calculation, right? So in the second use case, why 30 is coming under 40 branch? Why in second use case 30 is coming under 40 branch? See, here I'm trying to make a separation based on x2. So what is a threshold of x2? So whatever value that we have lesser than 50, so in terms of x2, it should fall in this region. So that's the region, so it's coming over here. So we are trying to keep a threshold of this one is equal to 20. And here threshold is equal to 50. So whatever value that we have in between 20 to 50 is falling in this particular place. That is the reason. Okay, so how to decide a threshold? Now, if you have to decide a threshold, you will have to look after a custom mechanism that has been designed internally inside all of this algorithm. So whether it's a ID3 or C4.5, or you can say successor of ID3, and a CART algorithm, classification and a regression algorithm, or maybe CHAD. So chi-square automatic interaction detection. That is something called as CHAD. So internally, you will be able to find out that sometimes, so we are trying to take maybe an average of it, and based on that, we are trying to divide. Maybe we are trying to create a different bins or different blocks. That okay, fine. So average and then divide by 2. So maybe we can divide this entire things into 4 different separations, and then based on that, so we are trying to create a threshold. So there are multiple ways by which we are trying to create a threshold based on the requirements that we have and based on the hyperparameter that we are going to choose. So this is how we are trying to create a threshold. So is this things fine to everyone? So are we able to understand how decision tree works in terms of a regression, and how decision tree is going to work in terms of classification? Yes. Okay, fine. Now inside a decision tree, again, you will be able to find out a multiple. This is ID3 and C4.5 and CART algorithm. So these are the three main algorithms you will be able to find out. Apart from that, so yes, there are algorithms, like I said. So CHAD is another algorithm, which is a chi-square based separations that will be applicable over here. But yes, if you are aware about these three, so I think you will be able to answer each and everything. And whenever someone is asking you that how decision tree makes a separations in terms of classification problem, or maybe in terms of regression problem, so maybe you can try to give this kind of example, and then you can try to explain that yes, this is how decision tree is going to create a separations, or maybe it is going to give you a final result based on all of these three examples. So now let's try to summarize our slide number 1. So here we were talking about three situations. So one is a feature, categorical, outcome, categorical. By default, it will be a classification problem. And we can try to solve this problem with the help of ID3, as well as we can try to solve this problem with the help of C4.5. If I'm talking about a feature is equal to continuous and outcome is equal to like a categorical. So again, we can try to take maybe a C4.5 and we can try to solve it. If feature is continuous, outcome is continuous, so we can try to use only and only CART algorithm, and based on that, so we can try to create a tree and we can try to solve this particular problem, and that is something called as CART. So ID3, C4.5 and CART. CHAD is another algorithm, chi-square based algorithm, so which can be used again to create decision tree for both the purposes. So it's completely fine. Now, inside a decision tree, you will be able to find out something called as post pruning and pre pruning. So let's try to understand this concept. What is the meaning of post pruning? What is the meaning of a pre pruning? Why this pruning is required? Because many people ask this kind of a questions again inside in an interview. So here, when we are trying to create a decision tree, it's completely fine. Sometimes you will face some sort of a issue. So maybe overfitting issue or maybe underfitting issue, you all are going to receive, because this is just a algorithm which works on separation of the data set. So we will keep on separating a data set, and based on that, it is going to give you a final result. So overfitting means, let's suppose I have built a model, and when I have tested it at the time of like a training, so my model has given me accuracy is equal to 90%. But when I'm trying to test my model with my unknown data set, at that point of a time, my model is giving me accuracy is equal to 85%. So 90% at the time of training, and when I'm trying to test it with my completely unknown new data set, so 85% is a result which I'm able to receive. So maybe there is some mistake that we have made, or there is some wrong separations that we have done with respect to a decision tree. Now that wrong separation is possible, maybe based on the number of branches that we have created, a threshold that we have opted for internally at the time of like understanding the pattern of the data set, or maybe on a leaf node, the way we are trying to do a calculation. So based out of that, it is giving me some sort of a wrong values. And this is where to rectify these things. So you, and to control all of these things, to control your overfitting and your underfitting problem. So there is a concept called as pruning, which is available with respect to a decision tree. So there is something called as post pruning. So post pruning is nothing but it's in another way. So it's called as a backward pruning. So here, in case of a post pruning, first of all, we try to build a complete decision tree. And then we try to identify that which branches are a kind of a branches which is not participating, or which branches are the branches because of that I'm able to get some sort of a overfitting or underfitting issues. And that we will be able to find out based on cross validation. So now what is cross validation? We will try to understand. So during a cross validation, so we try to tune a parameter, and then we try to find out that, okay, to build this entire decision tree, we have a certain categories or we have a certain criteria, and maybe this branch is not participating. Let's do one thing, remove that branch. So maybe if I'll try to take one of the recent example. So here, let's suppose I have divided my data set further, and in case number 3, it was giving me 25. I was expecting maybe 20 and it is giving me 25. So further I have divided this branch, and maybe because of that I'm receiving this kind of a error, or maybe this kind of a overconfident result. What I can do is maybe I can try to remove this branch. So I can try to prune this particular branch, and in that way my result will be rectified. So this is something called as post pruning. So when we try to send a data, a different combination of a data inside a cross validation. So I'll be talking about cross validation in very detail. Plus we have to do an implementation of that in our practical classes. So here, in case of like a cross validation, if we are able to find out that yes, this is a non-performing branch, if we are including it, our residual will increase. If we are removing it, our residual will decrease. So let's try to remove it. So that is something called as post pruning, so that we can see some sort of a improvement. And there is something called as pre pruning, right? Or in other word, it's called as forward pruning. So post pruning is a backward pruning. First build a tree and then try to remove a non-significant attribute or non-significant branches. In case of pre pruning, what we try to do is, so in case of forward pruning, so we try to stop our tree to generate insignificant branches, or maybe a non-significant branches. So if we are able to stop our decision tree to generate those kind of a branches before creating a decision tree, that is something called as pre-pruning. So here, how we can try to decide or how we can try to stop it? So maybe I can try to set a criteria that whenever you are building a decision tree, so don't try to build maybe beyond 3 layer. So don't try to separate any of the data beyond 3 layer. So maybe we can try to control a height of this entire tree, and in that way I will be able to achieve this particular situation. And that as a parameter we can try to utilize at the time of creation of decision tree itself. So it will not create. So if it is not creating it, for sure we are not supposed to remove it afterwards. So tree pruning is again a very important concept that you all will be able to find out. So where we always try to perform this pruning kind of a concept or pruning kind of approach with respect to a decision tree. Sometime pre-pruning, sometime post-pruning. So both of these approaches we try to test it, and then based on that we try to remove all of these branches. Same thing happens for your regression as well as a classification. So in case of a regression, so we always go after the summation of all the thresholds. Sometimes, so we can try to adopt some sort of a relation parameter as well. So if you know, or if you remember, we talked about a regression parameter in case of our linear regression. So we talked about L1, L2, or elastic net, risk lasso and elastic net. This is something that we have discussed. Now, over there, we were using risk lasso or elastic net to control a value or control an effect of our loss or error over a changes that it is going to make in M or in C. This is what we have discussed in case of a linear regression. So over here, again, this is something called as regularization. So in case of classification, so we are trying to prune our branches. In case of a regression problem, right? In case of a regression problem, so again, we try to do a tree pruning based on a same approach. L1, L2, we can try to apply, and then we can try to prune a tree. So we always try to realize that, okay, fine. So how it is trying to find out losses, and we try to control changes into losses. And yes, in this way, impurity of this entire tree will be as low as possible, and then we will be able to build it. So now let's try to understand one thing. So let's go to our official scikit-learn library, and then yeah, sklearn decision tree. Okay, so maybe we can try to look into this library. So how this library is well designed, and what and all parameters that we have, what and all parameters we can try to utilize for a pre-pruning or maybe for a post-pruning. So here you will be able to find out a multiple parameter. Actually, a lot of parameter you will be able to find out. One is called as criterion, one is called as splitter, one is called as maximum depth. And here, so for sure, you will be able to recall all the concepts that we have discussed. So I believe we talked about Gini and we talked about entropy, right? So Gini is nothing but Gini impurity. Entropy is nothing but based on that we can calculate a information gain. Agree, everyone? Yes. So here we can try to opt for Gini, or we can try to opt for entropy. By default, it will be a Gini. And I think we all are aware about the formula, 1 minus P of summation of Pi square, right? The function measures a quality of a split. So like whenever you are trying to split a data set, whether it's a continuous data set, whether it's a categorical data set. So what is the impurity that you will end up introducing? And whichever is introducing a less amount of impurity, that is going to be a root node. So support criteria as Gini for the Gini impurity and entropy for a information gain. So any of these two things I can try to select, Gini or entropy. And I think we are aware about the calculation in both the cases. Now splitter, let's suppose I'm going to open up a decision tree regression as well, so that we can try to check in parallel. So this is a classifier and this is a regression. So here, if we are using a decision tree classifier, so we can try to use Gini as well as we can try to use entropy. Now splitter, so best or random. So strategy used to choose a split at each node. Supported strategies are best to choose the best split, and random to choose a best random split. So maybe based on the random. So we are trying to split the data set, or maybe based on the best. So we can try to choose it. Maximum depth. So again, this is a parameter that we can try to control. So whether a depth of my tree will be 4, 5, 10, or whatever it is. Minimum sample split. So how many samples are required to create a split? So there is something that we can define. So minimum samples are required to split a internal node. So if that many number of samples are not available, in that case, it will not split. So let's suppose minimum sample is equal to 10. So again, if in one of the branches, we don't have like a 10 number of data set, it will not even go for the split. Now minimum sample leaf. So the minimum number of sample required to be at a leaf node. So this is a criteria again, which we can try to use at the time of pruning of the decision tree. So how many samples are required at the leaf node, so that I will be able to make a robust decision. So again, if I'm saying that, okay, 5 is required, if we have less than 5, it will not make a further division, because division wise, it will just keep on making a division infinitely. So that is not required at all. Now, minimum weight fraction of the leaf. So minimum weighted fraction of summation of the total weight. So what will be the weightage of each and every leaf node? That is something it try to calculate. By default, weightage will be equal to 0. Maximum number of feature. So how many number of features it will be able to consider, and it will be able to make a best kind of a split. Again, by default, so it is not going to take, or it is not going to fix any fixed number of the feature. Now there is something called as random state. Random state, I think we all are aware about it. So it's just like a seed function. It will try to fix a separations or a random separations. So it's just like a seed function that we have studied in our NumPy. Maximum number of leaf nodes. So if it is trying to grow, so grow a tree with the maximum leaf node in a best first fashion. Now minimum impurity decrease. So what is the minimum impurity that it will be able to decrease? Minimum impurity split. So what is the minimum impurity or threshold on which it will be able to perform the split? A class weightage. So what is the weightage it is supposed to give to a different classes that we have? A CCP alpha. So complexity parameter. So what is a complexity it will end up creating? So when it will end up creating a whole decision tree. So this is a parameter that is given to you, and this is the parameter that you can try to train, or maybe you can try to work on it. Apart from this, so these are the attributes that you can try to provide. So number of classes, number of features, number of outputs, and all those things. So this is something that you will be able to see in case of a classification problem statement when you are using a decision tree. Now here, there is a slight differences you will be able to find out. So criteria is Gini and entropy. So here, criteria is going to be mean squared error, or maybe a Friedman MSE, or MAE, or maybe a Poisson distribution. So just try to read out this one. So what this says anyhow. So here, the functions measure the quality of a split. So what will be your mean squared error? And supported criteria are MSE by default for a mean squared error, which is equal to the variance reduction as a feature selection criteria, and minimize the L2 loss using a mean of each and every terminal node. So it is going to consider a mean squared error, which will try to check what is a quality of your split. So if I'm trying to split now, what is the error which I will end up introducing? In case of MSE or mean absolute error, so again MAE we can try to take, which is nothing but modulus of y minus y hat square. And here features and criteria, and minimize the L2 loss using a mean of each and every terminal node. So I think we all are aware about L2 losses. Now Friedman MSE, so which uses a mean squared error with the Friedman improvement score for a potential split, MAE, for a mean absolute error, which minimizes a L1 loss using a median of each and every terminal node, and Poisson's, which uses a reduction of Poisson's deviation of the first tree. So this is something that it does to check that how good we are with respect to splitting an entire decision tree. So y minus y hat square. So can I say that it's approximately close to MSE? Yes. So MAE is nothing but modulus of y minus y hat, MAE, mean absolute error. If I'll talk about MSE, so it's nothing but 1/2 of y minus y hat square. So this is something that it is going to use. Or maybe I can try to use a Poisson distribution, so which will try to check that, okay, so we have done a split, but how good we are with respect to this particular split. Again, splitter wise, it's the same as the previous one. Sample split, again, it's same as the previous one, classification one. Weight, so rest of the parameter is completely same. So whatever parameter that we have seen in case of a classification, so same parameter you will be able to find out. Just a split criteria will be different over here. So in this case, so it's going to be MSE, or like a Friedman MSE, or maybe MAE, and then a Poisson distribution. Based on that, it will try to make a separation. So simple. Maximum depth is for pruning. So yes, Siva, it's been used for the pruning purposes. Again, if you have to check its code base, so this is a class. You can try to set your own parameter over here. You can try to convert, or you can try to change anything that you want, right? So MSC, MAE are these are loss functions. So yes, it's a loss function. And here is a fit method which will be used for a training. So when you are going to fit based on this criteria that we have discussed, it will start dividing a tree, and it will start creating your parent node as well as it will start creating your child node. So this is something happens in case of decision tree regression and a decision tree classifier. And now criteria wise, you will be able to find out each and every implementation. So yeah, uh, this is something that is there, which we will try to recall or which we will try to utilize it at the time of our practical implementation. So fine guys, I think we are good with our decision tree, and we can start doing some sort of implementation. Okay, so we will try to use a same algorithm, this classifier, as well as we will try to use a regression when we'll go for a practical implementation. And before that, so I believe we are supposed to talk about, okay, cross validation we'll discuss at the time of implementation itself. Hyperparameter tuning will also come into a picture. So yes, it is going to come into a picture, and hyperparameter tuning, we can try to do it based on cross validation. So there is something called as random search CV. There is something called as grid search CV. So with the help of that, we'll try to perform a hyperparameter tuning, and the best possible like a parameter we can try to identify. While setting a threshold, what method do we use? If we are using a card algorithm, right? So by default, when we are using a card algorithm, it can be used for a regression as well as classification. So based on the criteria which has been defined and based on the hyperparameter, it will start splitting. So it can go for the random split, or maybe it can go for a best split. So best split means it will do lots of permutation combination, sometime with mean, sometime with median, sometime with mode, sometime with other distributions, or it will try to define a category, maybe some sort of a threshold numbers that, okay, fine. So maybe a ranges of 2, maybe ranges of 5, and then it will try to experiment. That is something called as best split. Where is the parameter? So can we use ID3 for regression? No, you can't use ID3 for regression. ID3 has been designed just for a classification purpose, not for a regression purpose at all. Maximum depth means number of layers. Yes, it's true. Okay, so I think we can start talking about a new algorithm. one more algorithm. So based on the decision tree, so maybe we can try to discuss. So there is something called as ensemble approach. So here we were talking about a decision tree. That's completely fine. There is a chance or there is a possibility that we may combine a multiple decision maker, and then we can try to make a decision. For example, so let's try to talk about ensemble technique. Ensemble technique. Now, we talked about a logistic regression. We talked about a decision tree. We talked about a linear regression. So all those things are completely fine. Somewhere we were talking about regression. Somewhere we were talking about the classification. Somewhere we were talking about classification as well as regression. Like decision tree is an algorithm which can be used for classification as well as regression. That is fine. Now, there is another approach we can try to identify over here. So where we can try to use a multiple instances of a same algorithm, or maybe a combination of a multiple different algorithm to make a decision. So for example, in a parliament, if we have to pass any kind of a bill, right? So what do we do in general? So like a copy of bill will be given to all the parliament member. They will try to read out, they will try to discuss about it, and then finally they will go for a voting, and majority wins. if we have to vote for yes or no. If we are supposed to like propose some sort of a budget, so maybe x or like a x1 x2 x3 kind of a budget if we have to propose, so maybe every members will try to give some numbers, and we can try to go for an average, and that average will be a final budget. So this kind of a situation is possible. Now try to understand this situation as a whole. So here, let's suppose one parliament member, right? So let's suppose there is a member number one. He has received a bill, or she has received a bill, and he or she is trying to read out this entire bill. It simply means what? So can I say that they are trying to get some sort of a information about a bill in very detail, and they are trying to understand it, maybe according to their constitution or maybe according to their understanding. So they are trying to understand this entire bill so that they will be able to go for a vote, and they will be able to say yes or no whether we should pass this bill, or whether we should drop this particular bill. Now, so one member is trying to make a decision. So can I say that it's completely fine. All of them are like a selected member, right? Selected by people. So for sure, they are in a position to make a decision. But if one person is trying to make a decision, can I say that that may be a biased one? There is a very high chances that that particular member will end up making a biased decision. Possible, right? Anup is saying that jhagda karta hai parliament mein sir. Yeah, that's true. That happens a lot. So, okay. So for sure, if one member is trying to make a decision, so maybe that member is a biased one. What is a possibility? So the possibility over here is that maybe that member is not able to understand each and every perspective of that particular bill. Maybe that member is influenced by their party, because again in India, so we have a multiple regional and national parties, right? So every parties will be having its own agenda and its own like a propagandas for sure, and based on that they will try to make a decision, right? They will try to say yes or no. It's not like if bill is good for common people, so they will try to pass it. What they will do is, so they will try to consider their party's agenda as well, and again in upcoming elections, so how it is going to affect them, all those things they will try to consider, and how their party workers are going to respond. So based on that they will try to so it will be influenced, it will be influenced by many other data set as well, or it will be influenced by many other factors as well when one member will try to make a decision. But at the same point of a time, if I'll say like there are a multiple member, there is a member number 2, there is a member number 3, there is a member number 4, there is a member number 5. If they are trying to make a decision all together, so meaning is individually they are making a decision. So this member is an individual member and independent of other members. It's not like these two members are connected. No, this is a independent member, this is an independent member, this is independent, this is independent, and this is independent. Everyone is having a bill, everyone is trying to make a decision, right? Everyone is trying to make a decision. And then when let's suppose this member said yes, this member said yes, this member is saying no, this member said yes, this member is saying no, in terms of whether we should pass a bill or whether we should reject a bill. So can I say that it's called as voting? They all will go for a voting. So they all have made a individual decision, right? So they all are a decision maker in themselves, but final decision will be nothing but it's a voting and majority. So whatever like whether yes is going to get a majority or no is going to get a majority, so that will be my final decision. So if 3%, so yes is 3 and no is equal to 2. Can I say that in this case, yes will be a final decision? Yeah. So that is the final decision that we will be able to receive. So this is another way. This is another way of even training a data set, or this is another way of solving any kind of a problem. or maybe a best way or better way as compared to the previous approaches that we have used. So we have, if we are using one single decision tree, only one person is trying to make a decision. But let's suppose I have created 10 decision trees, and based on a random split, right? So randomly, I'm trying to select some of the data. Again, I'm not talking about columns, separate columns. I'm talking about records or rows. So let's suppose I have hundreds of records or 1 million record I have. So out of this 1 million record, some chunk of the record I'll just give it to member number one, then member number two, three, four, five, and so on. So everyone is having a sample data set, and everyone is trying to get some sort of understanding out of those data set, and everyone will try to adopt all of these data sets, and then finally they will try to make a decision. So which approach will be better, one decision tree or using a multiple decision tree at a time? So for sure, everyone will agree that using a multiple decision tree at a time will be a better approach as compared to using a single decision tree. And then if we are going for a decision. Now let's try to understand even in this way. So if I'm talking about a bias and variance, a trade-off, so in terms of making a decision, so can I say that if I'm trying to use a multiple decision tree, I will be able to reduce biases instead of using a single decision tree? Yes, so I will be able to reduce biases. So here we are trying to talk about a multiple decision maker, and this approach is called as ensemble technique. So wherever we are going to use, or we are going to ask a multiple decision maker to make a decision, so that kind of instance is called as ensemble approach or ensemble technique. So we are not just depend upon one single decision maker, so that I will be able to build a strong classifier or maybe a regression. Again, in case of a regression, everyone will try to give outcome. Then again, we will go for a averaging possible, and that average outcome will be a final outcome for a regression. So even in this way, I will be able to solve a regression problem. So ensemble is nothing but it's kind of a technique where in a different way, multiple decision maker will participate, and then they will try to make a decision. So this is not the only way. I talked about like a case of this, like a parliament, right? So this is one of the way by which multiple decision maker will be involved, and then they will try to make a decision. I'll talk about another story over here. So maybe I'm trying to do a transition, right? I'm trying to make some sort of a transition into a data science. So what I will do, maybe I'm completely new. I'm from a civil engineering background, right? I don't have any idea about like this data science technique or technology, right? I don't even know that what and all skill sets are required, what and all projects I'm supposed to mention, from where I will be able to get some sort of a help, where I will be able to do some sort of a project, right? So we are not aware about it, let's suppose. But still, I'm trying to make a decision whether I should go for a transition into a data science or whether I should not go in for a transition into a data science, right? I have to make this kind of a decision, yes or no. So whether I should start like preparing for data science or whether I should not start preparing for the data science. So I have a very few information. I just like got to know from someone that, okay, data science is a booming area. So maybe if I will be able to make a transition, my career will be good. My future will be secured for sure. And maybe I can get a better hike, a better compensation, better company possible, right? That is the only idea that I have. In that case, what you will do? Anyone? Yeah. So people are saying like you will just Google it. Some of you are saying just go for it. Okay. Ask multiple people. contact Einrons. Let's suppose you are not aware about Einron. So find a good mentor. Okay. Suggestions from the people. Construct a basic model. Okay. You're not aware about it, right? So how to create a model? So how you can create it basically? Ask a question. Ask the person to join. Okay. So let's suppose you're not aware about Einron. You're not aware about anyone. Just start learning data science themselves. But again, you will be directionless, right? So you have made a decision, yes or no. So how robust that decision is, that again matters a lot, right? So let's suppose you have started and for 6 months, you are just typing some code in a Jupyter notebook. Will you be able to make a transition? No, I believe. Let's suppose you know about all the algorithms, but you are not able to represent your projects into your resume. And you are not able to convert your experiences, previous experiences, right, in terms of a data science in your resume. Will you be able to get a call? So again, that will be a drastic decision that you will end up taking. So because a decision means what? Whenever we are trying to do some sort of a prediction and forecasting, so for sure that is a decision that we are trying to make. So again, decision must be a reliable one, right? And based on some facts and figures, we are supposed to make some sort of a decision. So people are suggesting me that we'll ask from multiple people, any suggestion from the experienced people. Okay, do a search of our requirements, uh, reach mentors. The answer, sir, maybe I'm not able to give a response then. As for me, the only option and improve your decision. I have many data scientists. Okay, so yeah, in this way, what you will do is, so maybe you will go to Google and you can try to search for it. And again, you will get confused that no, like Google is giving me so many options. Do this, do that. And again, if I'll search all the areas into a data science, so it is suggesting me that there is a ML, there is a DL, there is a vision, there is a reinforcement. So I don't know like which one to start in the first place, right? And maybe I don't have like that much of time, right? So in this way, I will try to find out someone who is having a better idea, or who is having a better like a perspective, or maybe a kind of a person who is having at least little bit of more idea as compared to me, or maybe little bit of more information, right, as compared to me. I'll try to search for that particular person. So I'll go to my friend and then I'll ask them that, okay, so I'm just like trying to switch into my data science things, right? So is it possible to switch? So friend will say, yes, it is possible. Then I'll ask how. So my friend will give me some sort of a tips, but again, there is a very high chances that my friend will be able to, or he won't be able to, or she won't be able to clarify each or every doubt. So again, I have received some information, I have received some decision that yes, I should go for it. But the problem is still I'm confused because I was not able to get all of my answer. Now my friend is already preparing for a data science, let's suppose. So for sure, he will be having another contacts, right? Or maybe another batchmates or someone, right, who is preparing for the same thing, or maybe a contact of the person so who has already made some sort of a transition. Now that person will go and ask another person that, okay, so I have my friend and he's from civil engineering. Based on my knowledge, so I have given him a suggestion that yes, you should go for it, and these things is required. So start preparing for these things, but maybe he is not able to make a final decision, right? So if you can try to clarify his queries and what and all efforts is required, in this way he will be able to make a better decision. So my friend is a kind, so my friend's a friend is a kind of an experienced person who is already working into an industry, in a data science industry, let's suppose, in which you are trying to make a transition. So he will say yes, yeah, and based on certain facts he will say yes for sure, because he's having more information, he's having more amount of a data set. So here he will say that, okay, so yes, it is possible from any background, anyone will be able to make a transition. Even people with the career gap will be able to make a transition. I myself has done that. In this way, he will try to propose. Plus, he will say that yes, if you are trying to do a preparation, so first of all, you should look into a coding part, right? It is important. If you are on a senior level, so maybe you'll have to look into architecture part, system designing part. Then a person is supposed to look into a statistics part a little bit. Then person is supposed to look into a little bit of machine learning part, little bit of like a deep learning part. If you would like to apply for all the available jobs into a data science industry, then you are supposed to look for a deep learning, computer vision, as well as advanced NLP part. If you would like to work into some of the research project going forward inside an industry, then maybe you will have to look into vision NLP, SOTA NLP for sure, and reinforcement part, right? So maybe my friend will try to clarify, and my friends of friend will try to give all this information. So now this civil engineering guy will feel happy that, okay, yes, I believe like I'm able to get all of my information. I'll ask like, okay, how much time it is going to take? So maybe it is going to take 6 months to 1 year of time, right? And so many queries this civil engineer person must be having. So if a person is able to clarify with all those informations, means a data, right? In that way, can I say I will be able to take a better decision? The final decision will be a best possible decision. So based on the capability, right? Okay. So can I say over here that again, multiple people are involved in terms of making a decision? Yes. Civil engineer guy who was confused. So yes, no, right? Friends of civil engineer guy who is doing a preparation in between, maybe more yes, less no, right? And then a person who is a part of industry. So he will now clarify that, okay, fine. So I'm giving you a surety. So yes, it is possible, but these are the things. So whatever decision you are trying to make, so try to make a decision based on these things. So can I say that again, multiple people are involved in terms of making a decision? And over here, can we make a statement that every time, so we are trying to boost our decision from person number 1 to 2 to 3. Yes. So person number 1 is trying to provide some information about his background. Then person number 2 is trying to add some informations on top of that. Person number 3 is trying to provide a complete information. And then based on that, can I say I will be able to make a better decision? So even over here, multiple persons are involved. Even in case of parliament, multiple persons are involved. But here, every individual is trying to create or trying to make a separate decision. Okay. So trying to make a separate decision. In second case, everyone is trying to make a decision. Everyone is trying to say yes, no, yes, no, yes, no kind of a things. Now, if I will try to go after the weightage, so can I say if civil engineering guy himself or herself is trying to take some decision, so weightage of his decision will be very, very less because he's not having all the idea and informations and data set, right? Based on that, he can decide. So maybe weightage of this civil engineering guy decision, weightage of decision of the civil engineering guy, C, I'm trying to represent him. So with V 0.001 plus maybe a weightage of this person who is doing some sort of operation will be 0.40, right? A person who is doing a preparation, and maybe a weightage of a person so who is trying to give a final solution or maybe suggestion based on a humongous data, or maybe a person who is working into industry, right? So that person is trying to give all the real things, and based on that person is trying to make a decision. So weightage of that particular person may be 0.80, so who is a industry specialist, let's suppose. So even in this way, can I say I can make a final robust decision? So where we are trying to consider a decision from everyone, but not with the equal weightage. And when we are trying to make a decision, so we are every time, right? So every time, so we are looking for a better decision maker. Yes. So from here to here to here, so can I say that we are trying to improvise our decision maker every time in every steps, right? So this is also an instance which falls under ensemble technique. So this is also something called as ensemble technique. So this ensemble technique is called as a bagging technique. and this is called as boosting technique. So here, in case of a bag, let's suppose I have a bag, right? So in my bag, I can try to keep a multiple like items, right? So in my bag, so I can try to keep a multiple items. So let's suppose I'm trying to keep a multiple decision maker inside a single bag, right? And every individual is trying to make their own decision, and the final decision will be a voted one or maybe a average one in case of classification, or in case of a regression, depends. In case of boosting, we are trying to involve a multiple person, but every time, so we are trying to find out some better decision maker, and we are trying to provide a weightage of each and every decision maker. So everyone is trying to make a decision, and every time, so we are trying to enhance it, right? We are trying to create someone, or we are trying to adopt, or we are trying to like take someone so who can give me a better decision, but with the boosted information and with the better decision maker. So these two techniques falls under ensemble technique. So meaning of ensemble technique is very simple: a technique where we involve a multiple decision maker. When we talk about a bagging, so inside a bag we have a multiple individual decision maker. Everyone will make a decision, and then a final decision will be an average or maybe a majority. In case of boosting, again multiple decision maker, but one will be a weak decision maker, other will be better than the previous one, the next one will be better than before, right? And everyone can make a decision, and final decision will be counted as a weighted sum of all the decisions that we are going to make from the individual decision maker. So that is something called as boosting. So we are trying to boost every time, right? We are trying to boost with a person who is having more amount of information. There is again another approach you will be able to find out, which is not that popular across our industry, but we do implement it, called as stacking, right? So here, in case of a bagging, what we do is, so whenever we are trying to make this kind of a decision maker, we always try to use a same nature of a decision maker. What is the meaning of same nature of decision maker? So let's suppose I'm trying to build one bagging model. So I can try to do what? I can try to use maybe a 10 decision maker, but all of this 10 decision maker will belongs to a same nature. It simply means that if I have a 10 decision maker, all of this 10 decision maker will be having either a decision tree, a property of decision tree, or maybe all this 10 decision maker will be a logistic regression, or maybe a naive bias, or maybe a KNN. So K nearest neighbor, or maybe any other algorithm we can try to use. But all this 10 decision maker will be same. If we are going to select 10 decision maker inside one bag, we are always supposed to keep a nature of like a kind of objects which is having similar kind of a nature, right? That is a restriction that you will be able to find out in case of a bagging. Stacking removes that. So stacking always works on a little bit of different principle as compared to a bagging approach. So in case of stacking, so let's suppose a very first model I have created based on a logistic regression. So inside a single like a ensemble technique itself, then I can try to use a decision tree, then I can try to use a KNN over here. So I can try to use a heterogeneous algorithm or heterogeneous instance over here in case of a stacking. Whereas in case of a bagging, I'm supposed to maintain a homogeneous decision maker in nature at any point of a time. If I'll talk about a boosting approach, in case of boosting approach, so yes, again, we are supposed to use an algorithm of a similar nature, and priority will be decided or given to me. So these are the three major things you all will be able to find out inside a ensemble technique. Idea is again very same in all these three. Involve a multiple decision maker. Somewhere we are involving a similar nature of the decision maker. Somewhere we are involving a decision maker which is having heterogeneous in its nature. So is it fine to everyone what is a meaning of ensemble technique? Why ensemble technique is important, why ensemble technique is better than, or ensemble decision makers are better than a individual decision maker, right? What is the meaning of a boosting, what is a meaning of a stacking. So hopefully meaning of stacking is not clear as of now, so this will be clear once I'll show you the like implementation, right? So real meaning of stacking you won't be able to understand as of now. I'll show you, and I'll show you with respect to an example. I'll take a data set, I'll take a multiple algorithm, and then when I will explain you, stacking will be very, very clear as of now. As of now, just try to understand that we have a stack of algorithms. So one will be a very first algorithm which will give an output. Now this output will go inside this one, this output will go inside this one, and this final one is going to give me a final decision. That is something called as stacking. But again, on a very high level, I'm talking about this definition of stacking. When I'll explain you, I think you all will get to know that what is the actual meaning of a stacking. So these three concepts are very, very important, again, from an interview perspective and from a machine learning perspective. When we will be talking about a bagging, we will not just experiment with a random forest. There is an algorithm called as random forest that I'll discuss in some time. So we will not just experiment this one with the random forest, but we'll try to experiment this bagging technique with other algorithms as well, like a naive bias, like a KNN, like a decision tree, individual decision tree. So there are multiple permutation combinations are possible just inside a bagging. Again, inside a boosting, multiple algorithm, ADA boost or gradient boosting or maybe XG boost. So these are the algorithms which will be involved inside a boosting. Inside a stacking, same algorithm that we are going to study, but arrangements wise, it will be different. But these three concepts are very, very important, and you can receive multiple questions on top of these three algorithms. So is this idea clear to everyone? Yeah. In boosting, we'll do a voting or not. So actually, we try to set a priority. We try to assign a weightage of your decision in terms of a boosting. So don't worry, I'm not done with your boosting things. So when I'll try to explain, so hopefully this idea will be very, very clear. As of now, I have just given you a layman kind of example, just to like a correlate, right? How this things is going to work. I have not given you even a technical example. So just wait for your technical example. And when I'll explain this mathematical concept, things will be very, very clear over there. Bagging and boosting have a homogeneous algorithms, and boosting have a weightage for every model. As of now, yes, as of now, right? When I'll discuss these things in a technical way, so by explaining its mathematics, so I think you will be able to get a better idea. How boosting is done, how to find a better function. Just wait for your classes, right? So in the book, you suggested there is no naive bias chapter. Are these not important? No, these two things are important. Yeah, so I'll discuss whether it's there in your book or not, but I'll discuss. I told a same example, so in one of the interview where I was selected long back. Okay, that's great, Ajit. Yeah. Stacking contains which type of algo? All type of algo. So that is a beauty of stacking. So here you can try to utilize. So see, these are the arrangements. Ensemble technique is nothing but it's kind of a arrangements in such a way that your base algorithm will be able to contribute maybe with others algorithm or other same base algorithm to make a decision. The idea over here is not to involve only one person or one decision maker to make a final decision. Involve a multiple one and then calculate a final result. That is the idea. So any algorithm can walk over here, and any algorithm can be a base algorithm in this particular place. But again, depends upon a technique that we are going to use. So that will be my answer for your question, Deepak. So stacking contains which type of algo? Almost all. Bagging avoids overfitting. So see, again, I'll not say yes. In many places, you will be able to find out that, yes, if you're going to use a bagging, so for sure it is going to reduce the biases. It will try to balance the variances, and then it will try to avoid a overfitting. But when you try to see these things with respect to a real-time data set, your perspective will change. Need to talk in a person. I got offer letter from Wipro, sure, Mohit. So after a class, we'll for sure discuss. So please allow me some time. Hypermeter can be tuned. Yes, how? I'll show you in a class itself. Okay. So now let's try to talk about one of technique out of an ensemble technique called as bagging. right? So let's try to talk about it. What is the meaning of bagging? Ensemble technique means multiple decision maker. If multiple decision maker will be involved, so that is a part of your ensemble technique. So shall we take a break of 10 minutes and then we should like talk about this new algorithm? Yeah, because I have a plan to talk about like implementation part maybe in tomorrow's class, or maybe we can continue with the theoretical part. We can try to close all this algorithm, and then mix up of all the algorithms are very much important, right? So we talked about logistics, we talked about decision trees, and again inside the decision tree, so multiple like algorithms, multiple variances. So what my idea over here is that let's try to talk about algorithm theoretical part back to back, so that by the time we will discuss your practical part, so you will forget something for sure, right? In 1 week you will not be able to remember each and everything. So when we will do a practical, at that point of a time, it will be a kind of a revision. We will be able to recall all of those things. I want you to forget all those things that we have discussed, so that in a revision, so I think you will be able to retain it, you will be able to recall it in a better way. Yeah. Okay. So fine. Yeah, algorithm cocktail. Yeah. So fine, guys. Let's take a break of. I think 10 minutes is fine for every one of us. Yeah. So let's try to complete all the algorithms in a theoretical way, right? So that by the time we'll discuss your practical, uh, you will forget something, some of the parameter, libraries, and all those things which I want for sure. And then like all means which all. So maybe back to back 6-7 algorithm. So DVC task, so Swam, it's like tomorrow. Tomorrow is a deadline. Practical would be next week. Let's see. Depends. I can even start practical of dysentery today, but let's talk about this theoretical things. Yeah, sure. So fine, guys, take a break and then we can start talking about other algorithm. So now it's 5:10. So by 5:20, so we'll resume and then we will start. Yeah. So we'll start with the bagging classifier as well as bagging regression. For a DVC task, tomorrow is a deadline. Yes. Okay, so fine everyone, I think we all are back. So we were talking about this ensemble technique. So inside ensemble technique, so we were talking about a bagging technique. So let's try to understand what is a bagging technique and how this algorithm is going to work in general, right? So let's suppose there is a training data set which is given to me. So now there is a training data set which is available to all of us. And there are two classes which is involved at the time of training, right? So this is maybe my x1 and this is maybe my x2. So again, dimension of this entire data set is this one. Now there is a possibility that out of this data set, I can try to create a multiple data set, or maybe I can try to sample out a multiple data set over here, which can be a combination of, or maybe a subsample of any of this given data set that we have already taken or that we have already considered, right? So I'm just trying to draw this data set. So this is a sample data set that we have created over here. And again, this sample data set is nothing but it's a sample of this original data set or population data set that we have taken. So in this way, can I say that I can just try to divide a data set which will be having a combination of each and every data set over here? Yes, everyone? So now this technique is called as a bootstrapping technique, or it's called as a bootstrap aggregation. So let's try to understand what is a meaning of bootstrap aggregation or bootstrapping technique. In other way, it's called as bagging. So in case of bootstrapping technique, first of all, we try to sample a data set from the population data set. And this bootstrapping technique is nothing but a data set selection or sampling of a different kind of a data set from an original data set with a replacement. With a replacement means there can be an overlap. So it's possible that whatever data set that we have considered over here, so maybe some sort of a data set will be available even over here, some sort of a data set will be available even over here, and some sort of a data set will be available even over here. So I'm talking about a row, or I'm talking about a record label. I'm not talking about the columns, because in every data set, number of features is going to be same. Features are not going to be different at all. Number of features means if I have x1 and x2 in my original data set, so for sure in other data set I will be having x1 and x2. So here what I will do is, so maybe I can try to just sample, and then on top of this data set, this data set, this data set, and this data set, I can try to apply an algorithm decision tree, which is a subsample of my original data set. Now, this is going to build my decision tree one. This is going to build my decision tree two. This is going to build my decision tree three. This is going to build my decision tree four out of this subsample data set. Now, this decision tree is going to make a certain decision, right? So maybe if I'm trying to like make a decision, yes or no. So this decision tree is saying yes, this is saying no, this is going to say yes, and this is going to say yes. So in that case, yes is equal to 3 and no is equal to 1. So for sure, a decision, final decision will be a yes in that case. Or let's suppose if I'm working on a regression problem, so maybe this is going to give me some outcome, this is going to give me some real number, this is going to give me some real number, all of these four is going to give me some real number. What I will do is I'll try to sum up all this real number divided by 4, because we have a 4 decision maker over here. So we'll try to take an average of each and every decision maker that we will be able to build, or we'll be able to receive over here. So this technique is called as bootstrap aggregation. So bootstrapping is nothing but it's a way by which we divide a data set into a different samples with an overlap, or I can say with a replacement, or using a replacement. So we are just trying to replace some data set with some other data set, and then we are trying to build some other sample here. So someone is asking me a question that y is equal to 2, n is equal to 2, then what will happen? So for sure there is a class and you will not be able to make a proper decision. And in that case, your decision maker is not strong enough. And in real time, let's suppose if I have a millions of record, and then if I'm able to build hundreds of decision maker or maybe 1,000 decision maker, this is not going to be a situation. So out of thousand of decision maker, let's suppose I have built 1,000 decision tree, right, inside one of the bag. So in case of 1,000 decision maker, it's not like 500 will give you yes and 500 is going to give you a no, right? In our parliament itself, so we have 500 plus members, and out of this 500 plus members, you will be able to see that it's not like half of the member is going to say yes, half of the member is going to say no. So same. Uh, so there is a chances. If there is a class, in that case, you will have to rebuild your decision maker. If you are going to see a repetitive class, means you are not able to make a decision. You are able to reach out to a position which is kind of a contradicting position. So we'll try to rework on our decision tree, or maybe the way we are going to build a decision tree, right? Or the way we are going to build this entire models. Here I have written decision tree, right? In case of a bagging. But decision tree is not a only algorithm which you can try to utilize in case of a bagging. Maybe I can try to use a naive bias, possible. Maybe I can try to use a KNN. Maybe I can try to use a SVM. Maybe I can try to use a logistic. So any of these algorithm I can try to use for any of these purposes, right? Uh, so decision tree is not a mandatory one, but yes, at any point of a time, if I'm trying to build one of the bag, right? So inside one of the bag, whatever algorithm I'm going to choose. So let's suppose I'm going after a KNN. In that case, all of this algorithm will be a KNN. All of this decision maker will be a KNN. If I'm going after a decision tree, in that case, all of these algorithms will be a decision tree. If I'm going ahead with SVM, support vector machine, classifier, or maybe a regression, so in that case, I will be having all of this decision maker as a SVM. So that is a protocol, that is a rule that we all are supposed to follow while we are trying to build any kind of a bagging classifier or maybe a bagging regression. So that's a bottom line that we all are supposed to follow, right? So this is again in an interview, people ask a question that what do you understand by a bootstrapping technique, right? So bootstrapping is nothing but it's a way by which we will be able to divide a data with a replacement. That is actual definition of bootstrapping. And when you are going ahead with a bootstrapping, so for sure it is going to decrease variances, because we are trying to take a different variants of a data set in a different samples without increasing any kind of a biases, because every individual decision maker is having its own subsample of the data set, and based on that it is trying to make some sort of a decision. There is something called as, so there is another technique. So one technique is called as bootstrapping technique, the way we are trying to select a data set or the way we are trying to divide a data set. And there is another approach, or there is another technique which again comes into a place when we are talking about a division of a data set, called as pasting. So pasting is another approach. Let's try to talk about it. Again, it's a very small and simple concept. Pasting. Now, what is the difference between bootstrapping and a pasting? So you can try to maybe use even this technique to divide a data set, but without replacement. So if you remember, right, we all used to do a train and test split. So is it a bootstrapping way or is it a pasting way, pasting approach? So can I say it's called as it's kind of a pasting approach, right? So it's kind of a pasting approach. Whenever we try to call a train and test a split, again, theoretically, right? So theoretically, it's kind of a pasting approach. Uh, where we are trying to divide a data set, but none of the data set will overlap and none of the data set is going to repeat itself. So in our training set, so there will be a separate, again, training and testing is nothing but subsampling of the records. We try to do just a sampling, right? So we try to divide a data set into 70 is to 30, or maybe 80 is to 20, or 60 is to 40, whatever kind of a division that we are going to make. But again, in case of training and a testing data set, it is not going to overlap at all. But in case of a bootstrapping, yes, there is a very high chance that you will be able to see a kind of overlap, a kind of repetitions, or a kind of a similar data set in two samples that you are going to create. So training, just to remember this idea, right? So training and testing split, you can consider as a pasting approach. So where there is no overlap, and bootstrapping is nothing but dividing a data set, but with a mixture. So there can be an overlap. Now let's try to understand a concept or idea called as a random forest. So I was talking about an ensemble technique. Inside ensemble technique, we had a bagging. Inside bagging, I told you, we divide a data set, right? We divide a data set with certain overlaps. Let's suppose, means there will be some common data set in between all the samples. It's like even this has selected like maybe let's suppose this data set, and this has also selected the same data set possible, right? Because we are using a bootstrapping technique to divide this entire data set. That is completely fine. I told you that we can try to use any algorithms, any classifier, majority of the classifier, I would say. So majority of the classifier or majority of the regression, I will be able to use inside this bagging technique. Means inside a particular bag, I can have any kind of a decision maker. I can have any kind of a algorithm that we have already studied or that we are going to explore in a future classes. That is fine. But there is a specific algorithm you all will be able to find out, and it's called as a random forest. So random forest is one of the algorithm which is a part of ensemble technique bagging process. So inside this ensemble technique bagging, you can use this random forest directly. Now, so whenever we are talking about this forest means what? Can I say forest is nothing but a combination of a multiple tree? Yeah. So forest is nothing but it's a multiple trees, right? Combination of trees. That is something called as forest. So again, this name itself will give you all the clarification that what is the meaning of a random forest. Random forest. So random forest is nothing but it's a combination of a decision tree. I told you in my previous slide that we can try to use a decision tree. So here we are using 4 decision trees. So can I say that we have a forest of 4 trees? Yes. So here in this case, can we say that we have a forest of 4 trees, right? Over here, it's completely fine. Now, many people get this kind of a confusion that we can just try to use a decision tree in case of a bagging approach. And whenever we talk about a bagging approach, so people always talk about a random forest. They never say that we can try to use some other algorithms as well. So maybe a KNN, maybe a SVM, right? Or maybe like a naive bias we can try to use. Very few people talks about it, right? So let me clarify these things. We can use any algorithm inside this bagging process. Inside a bag, I can have any kind of algorithm, and for that I'll show you a practical implementation as well. That's the reason so I'm trying to wrap up multiple algorithm, right? So that in a same approach I will be able to show you a multiple approaches. That bagging is possible even with the help of KNN. Bagging is possible even with the help of individual decision tree. Bagging is possible even with the help of SVM, right? Bagging is possible even with the help of a naive bias. Plus bagging is possible even in random forest algorithm. The only difference is by default inside a random forest, you will be able to use only one algorithm as a base algorithm, and that is a decision tree algorithm. That's the only differences you will be able to find out. But concept of bagging, right? So random forest is one of the specific algorithm which falls under bagging, but it's not like in terms of bagging, so I won't be able to use any other base model. So base model can be anything, because that is what concept of bagging is, right? So means I can try to create a bag, and inside that bag I can try to keep any kind of algorithm. The only constraint over here is all the algorithm having must have like a similar kind of a nature, right? So if I'm using SVM, and inside my bag, if I have like a 10 decision maker, so all this 10 decision maker will be a SVM. If I'm using KNN, so all this 10 decision maker will be having like a property of KNN. That's the only thing, that's the only restrictions you will be able to find out in case of a bagging classifier. I'll show you even in a practical implementation, right? Okay, so now let's talk about this specific algorithm called as a random forest. And that's the reason I told you that try to focus on a decision tree, because random forest is nothing but just a decision tree. The only thing is we are trying to combine a decision. That's it. From a multiple decision maker. Apart from that, you won't be able to find out even a single differences. Apart from combining a decision from a multiple decision tree, you will not be able to find out. So the concept of Guinea, a concept of like a information game, a concept of ME, so mean absolute error or mean square error, or maybe a concept of like a difference between y and y hat, residuals that we have discussed. Everything is applicable even over here when we are talking about a random forest, because base algorithm is not going to change. The way we are trying to create a final model, that's the only changes that we have over here, right? Okay, so like I told you, if you are going to use this bagging technique, so for sure you will be able to decrease our variances, which is very, very important. At the same point of a time, without increasing a bias, without increasing an error, you will be able to decrease, or you will be able to control variances at any point of a time. So now let's so I think like this idea is pretty much clear to all of us, right? That what happens in case of bagging, and then how bagging behaves, and what is the meaning of a bagging, what is the meaning of a ensemble technique. So let me clarify. Inside this ensemble technique, there can be a three approach: bagging, boosting, stacking. Now inside a bagging, so I can try to create a bag with the help of SVM, with the help of KNN, maybe with the help of like a naive bias, maybe with the help of decision tree, individual decision tree, or maybe with the help of a random forest by default, which is going to use it, right? We'll talk about a boosting, so how boosting works, and then what all algorithms comes into a picture. But as of now, try to understand this one. In other word, it is called as bootstrapping technique as well, because the way it is going to divide a data set, based on that we are saying it's always follows a bootstrapping technique. So it never follows a pasting technique. Pasting means a data set sampling without any kind of overlap, like a train and test split. Boosting means, so we are trying to select a data set, we are trying to make a separations, but there may be some sort of a overlap. You all can find out over here, right? Now so here, advantages and disadvantages wise, if I'll say, right? So in case of a bagging, you can try to use you can try to use this bagging technique for regression as well as classification, because we all know that if base algorithm is going to support regression, so you will be able to do a regression. If base algorithm is going to support classification, so you will be able to do a classification. Now if you are trying to use this bagging approach, right? So again, depends upon the more like a base model. So let's suppose my base model is decision tree, and decision tree is good while handling missing values. So people will ask you a question that, let's suppose if I have missing values inside my data set, and I don't want to handle all of those missing values. So maybe I'm looking for an algorithm which will be able to handle missing values automatically. In that case, what will be your best possible algorithm? So whatever algorithm that we have discussed, based on that. So can I say that decision tree? Because decision tree is trying to create a threshold, and based on the threshold, it's trying to divide the data set. So even if I have some sort of a missing values, that's completely fine. That's manageable, and we will be able to separate a data set. So again, if you're trying to use a bagging technique, and if you are trying to create a bag which is based out of a decision tree, where base model is a decision tree, so I think that will be a better idea. And again, the another advantages you will be able to see over here is, so it always gives you a very accurate result with a low variance, and a very low biases, or maybe without changing anything into a biases. So again, it's kind of a stable algorithm, because here it is going to give you a result based on multiple decision makers. So variances will be very, very low, and even biases will be a controlled one, or maybe you can say it will be a low, right? The only differences, or the only like a drawback that you all will be able to see uh, when using this bagging technique is that when we are using a random forest, right? When we are using this individual algorithm to create a bag, it's completely fine. But by default, a random forest try to create a multiple decision tree internally, right? Without like a so let's suppose I said that, okay, fine. So inside the random forest, so try to take maybe 1,000 decision maker. So here you will not be able to figure it out that, okay, so how an individual 1,000 decision maker is created. That's the only disadvantages. Whereas when I'll show you a decision tree, I'll show you a graphical image as well, that how my system has separated a data set. That is possible in case of a decision tree. So the way we have done a calculation, right, in the similar way, exact similar way, right, even for a very, very complex data set, I will be able to see a very clear picture and a very clear number. I'll show you one sample. So this is something that we are going to generate. So let me show you a sample in case of a decision tree, and what I'm trying to like discuss over here. So we are going to build a decision tree, right? And as of now, what we have done is, so we have built this decision tree, and we have done certain sort of a calculation by our hand, right? And we have taken just a dummy record, because again, we won't be able to do a complex calculation just for the understanding purpose. So we have taken a very simple data. But when we will try to build a real decision tree, it's not like we will try to take a sample data set. So we are going to take some of the real complex data set, and then based out of that, so we will try to build a decision tree. And this is how your decision tree looks like, right? The real one, and even more like a complex than this one. Again, depends upon my data set and the way we are going to tune our parameter. So this is something that is possible to access, and this is something this which is possible to visualize. And each and every node that we are creating, right? So we will get to know that, okay, fine. So if this separation has been made, so based on what threshold, based on what Gini index, or maybe a entropy, or maybe information gain, this separation has been designed. So maybe I'll try to show you some smaller picture over here. So just try to look into this particular picture. Yeah. So here again, don't try to understand this picture, just try to understand the concept behind this branching. So here, can I say that you all are able to see like some sort of a Gini values, right? Some values, some separations, or something you all are able to see, you all are able to visualize. So this is possible in case of a decision tree. So if I'm going to create an individual decision tree, I'll get to know that, okay, fine. So this is how internally tree has been created. And there is a library by which we can try to see it. But at the same point of a time, the disadvantage which I was talking about. So at the same point of a time, if I'm using a random forest, I won't be able to get that clarity, that what kind of a decision tree it has constructed, and then what it is doing internally. So that is the only disadvantages you all will be able to find out while using or while building this particular algorithm, or while using a random forest. So that is the only disadvantages you all will be able to find out. Apart from that, so there is no other disadvantages you can see. So I think this part is clear to everyone. So what is a meaning of like a random forest? So random forest, nothing but it's actually a decision tree. The only thing is we are just trying to combine a multiple decision tree together. Or bagging is nothing but it's just a combination of your multiple base algorithm. Yes. Okay. We prefer random forest because so we'll see. So I prefer XGBoost sometime. I prefer even a stacking sometime. So we'll try to find it out. So which one is going to work well with our case, with our data set, and again with respect to a different data set, which is going to work well, right? So bagging में observation repeat होते हैं. What about features? So observations, yes, it is going to repeat for sure. Like I said, so it is going to create a data set without replacement, right? So yes, sorry, like yeah, with replacement, it is going to create a data set. So for sure, it is going to repeat. So random forest, nothing but पेड़ों का झुंड. Yeah, that's a good way to remember. That's true. Okay. Now, so drawback of bagging, I think I told you, right? So only drawback of bagging is, so the way it is dividing a data set in between your base algorithms, it's a little bit difficult to find out that which one is taking what exact sample of my population data set. That is the only disadvantages you will be able to find out. Otherwise, you won't be able to find out any other disadvantages. So that is something called as random forest. Now, coming to a second part, which is called as boosting, right? So Ensemble is actually a very simple approach, right? Theoretically, like there is nothing much to discuss in case of bagging technique. So we have to discuss about, or we have to talk about individual algorithm. Like SVM, we have not discussed. So we'll discuss KNN, we have not discussed. So we'll discuss naive Bayes, we have not discussed. So we have to discuss. So in case of a bagging, you are supposed to be very, very good with all this base algorithms. So far, we have just talked about this algorithm, which is a decision tree. In the similar manner, so we have to discuss about a naive Bayes, we have to talk about KNN, and then we have to talk about a SVM, all of these things, and then we can try to utilize it in case of a bagging. So basically in bagging, we select the best decision tree, which gives us the best result. No, in case of bagging, we try to build a multiple decision tree. Multiple decision tree will give me an output at a time, and then I'll go for a voting. This is what I have explained right over here. So when I was talking about this ensemble technique and bagging technique, this is what I told you. And yeah, so this is the concept that we have discussed. Okay. Does random forest also take any algorithm other than decision tree? No, not at all. I have again like clarifying this concept. So no, it is always going to take only one algorithm, and that algorithm is going to be a decision tree by default. But there is a possibility, but you can create a bagging model with other algorithm as well. This is what I said. Okay. So again, where pasting comes, sir, I'm a little bit confused. So see, pasting is just a way of doing a separations, right? In between a data set. So the way we are going to create a sample. So let's suppose if I'm creating a sample without replacement, means I don't want any kind of a overlap. So let's suppose I'm trying to create a 10 decision maker. Let's suppose there are 10 members in a parliament and everyone has received a bill. But in every bill, right, if none of the bills are overlapping, meaning is, so let's suppose there is a 10 like a member, and in a bill I have 10 chapters. Chapter number 1 will go to member 1, then chapter number 2 will go to member 2, chapter number 3 will go to member 3. In the similar way, chapter number 10 will go to member 10. So can I say that all of these members won't be having an idea, clear understanding about the whole data set or summary of the bill? Agree? So we are dividing a bill. Let's suppose bill is a data, right? So bill is a data. Final bill is my data set. So let's suppose I'm trying to divide a bills into a chapters, right? Chapter number 1, member 1, 2, member 2, 3, member 3. Now they are trying to make a decision that whether we should pass a bill or not. This is situation number 1. Situation number 2 is, so yes, bill is available to all of them. Same bill is available, let's suppose, to all of them. Some people will try to read out maybe 3-4 chapters. Some people will try to read out 4-5 chapters. Some people will try to read out 6-7 chapters. Some people will read out all the chapters, right? And then they will try to make a decision. This is case number 2. So in which case I will be able to make a better decision? So we have 2 cases, right? Yeah. So for sure, in a second case, we will be able to make a better decision, because like in a case number 2, a person, a parliament member, have read out like 2 chapters, 3 chapters, someone 4 chapters, 5 chapters, someone 6 chapters, 10 chapters, right? they have gone through. So for sure, they have a better understanding about the entire data set. So for sure, they will be able to make a better decision. So that is the reason in bagging, we always prefer to use a bootstrapping technique to divide a data set, not a pasting technique. So first one is a pasting technique. Second one is a bootstrapping technique. Is it fine? Yes. So random forest under bagging would mean, example, there are 5 random forest in a bag. No, 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 no. So random forest is actually a one of the algorithm, one of the final algorithm you can say inside this bagging technique. So random forest by default considers a multiple decision tree. So if you will create a multiple random forest, so in that case, what will happen is that we have a multiple decision maker, and inside that we have a multiple decision maker, right? So we are not talking about that concept. We are talking about just one label or one layer where we have a multiple decision maker, not a multiple decision maker inside a multiple decision maker. That is possible actually in case of a stacking. So when I'll come back to stacking, so I think I'll talk about it. That is possible again, but in case of stacking. I heard an analogy of bagging concept in arranged marriage when family members vote for a bride or a groom based on something each like in the bride or a groom. Okay, maybe I'm not able to like resemble these things. What is random in random forest? The random is the number of a tree that you are going to take, or base decision maker. So there is a possibility that I can take 100 decision maker or maybe 1,000 decision maker, right? So I don't know how many decision maker I'm supposed to take. And this answer you will be able to get out of cross validation. So we are going to apply a cross validation, and this random is nothing but a number of estimators are nothing but it's a hyperparameter that we have to tune, and then so that is something called as random, and plus the way it is going to divide a data set internally. So random forest uses a bootstrap to generate a multiple data set as it uses a bagging approach. Yes, that's true. So bootstrapping and pasting is just a way to divide a data. That's it. Pasting is a sampling without a replacement. Two. In bagging, is size of some sample same as the original data set? No, size in terms of number of rows if you're talking about. So no. Subsample means for sure subsample must be having a smaller size as compared to the original data set size that we have, right? Okay. Now, so just try to understand over here a new concept called as boosting. So bagging we have discussed. Now bagging we have discussed. Let's come to this one, boosting. So here you will be able to find out a heavy mathematics. So be ready for it and try to focus over here for maybe next 1 hour, and then we can take a questions, right? Because this is a math heavy operations. So you have to understand this part, and this part is again very, very important. All of these parts is important, but people try to focus more and more on this concept. So in an interview, so boosting. And here is a mathematics of boosting. Let's try to understand it. So in case of boosting, if you remember, I have given you an example. I have to make a decision that whether I should go for a transition into a data science or not as a civil engineer. So what I will do is I'll just try to ask my friend that, okay, fine. So what is your thoughts? What is your approach? So my friend is having a better idea. He's having a better data set. Maybe based on that, he's trying to suggest me. But again, he's not able to suggest me in a proper way. So he has asked his friend who is already a working professional. So this is an example which I have given to you. So where we are trying to start from a weaker decision maker, a person who is very weak in terms of making a decision. So he is trying to provide his information and his final decision to a next one. The next one is trying to analyze all of these things, all of this fact that he's from a civil engineering background and he's from this, that, and based on that, he's trying to say something extra or maybe something robust. Then there is a next decision maker who is trying to again take all of these inputs, and then the next decision maker is trying to give a better decision. So this is something called as boosting approach. Just go after the name, boost, right? So every time, so we are trying to boost a decision made by a decision maker. So we are starting off with the weaker classifier, then bit stronger, then a little bit stronger as compared to the previous one, and then a next one. So in this way, if we will try to build a model, for sure, I will end up building a best possible model. And this is a concept of a boosting. So here you will be able to find out a concept of a weak classifier. And in a technical term, a weak classifier is nothing but it's a kind of a decision maker, or weak decision maker is nothing but a kind of a decision maker who is better than, slightly better than, you can say, a random guess. So let's suppose a civil engineer is trying to make a transition. So for sure, that person will be blank, that what to do, what not to do, how I will be able to make a transition. So if that person is making a decision, so for sure, it will be a disaster. Or maybe it will be like nothing but it's a random decision that he is trying to make. That, okay, fine. So AI is a very good field. So maybe I have to like do some sort of a preparation in data science. So let's start doing it. So that will be kind of a random approach. But if he's or she is going to take some sort of a like a idea from someone else, if he and she is going to rely on someone else's decision who is better than this person, so for sure, the final decision will be a good one. Based on this approach, this entire things is been created. So now let's try to understand mathematics behind this one. Then you will be able to understand that how. So when we are trying to say we are starting ahead with the weaker classifier, then we are trying to build a better one, then a best one. So how we are trying to start from this weak classifier, then we are trying to build a better one, or maybe a best one. So once you will be able to understand this mathematics, which I'm going to explain you now, then this concept or this idea will be very, very clear. So let's suppose I'm trying to build a model, and I have in total, right, n number of sample, right? N number of records I have, or rows I have. So that is the meaning of n. So capital N, by which I'm trying to represent, right? Now, let's suppose I have m number of a decision maker, right? So maybe a final classifier, or maybe m number of model. So m number of model I have. So n number of total sample, total number of record, m number of decision maker. So in our case, there was 3 decision maker. One is a guy from a civil engineering background, his friend, and his friend, right? So let's suppose we have 3 decision makers. So how they all will be able to make a decision, let's try to understand. And we have to make a decision, yes or no, right? So decision wise, we have to make a decision, yes or maybe no kind of a decision, or maybe I can try to represent 1 or -1 kind of a decision. This is the decision that we are supposed to make. So is it clear? What if he thinks nobody is better than him? Then he himself is a disaster, Rohit. Okay, so fine. This idea is clear. What is the meaning of n? What is the meaning of m? Because these terms are very, very important, right? When I'll try to explain the mathematics part. So n is a number of sample. M is nothing but number of decision maker, right? And D is nothing but final decision. So yes, no, or maybe 1 - 1. This is my representation. Simple. Okay. Now, so what we will try to do is, so we will try to initialize. So let's suppose we have n number of samples, right? And I don't know that which sample is going to give me a better relation. I'm literally I don't have any idea. Let's suppose I have 1 million record, right? So I don't know which record is going to give me a better like a relationship in between a data set. I'm not aware about it. Because I have like a 1 million records, 1 million number of rows I have, or data set I have. That is completely fine. So here, what I will try to do is, right? So I will try to initialize a weightage. So I have n number of records. So row number 1, row number 2, row number 3, row number 4, row number 5, right? So in all of these rows, we have, let's suppose, x1, x2, x3, and y. And I don't know that which row is going to give me a proper like a decision, or maybe which row is going to give me a proper meaning, because as a whole this data set makes sense to me, but I don't know like which record is trying to represent, or which combinations of the records is representing a true relations, right, which I'm trying to find out. Or let's suppose this civil engineer guy is having some sort of information. You can try to resemble these things with the row record that we have. Now, the civil engineer guy is having information that AI is a very good field, and yes, data scientist like gets a very like a handsome salary, and they have a beautiful career. All those information, all those data set they have, but he don't know to which data set I'm supposed to give a weightage, right? So, handsome salary, good career, all those things is fine, but you are supposed to consider some other data set as well, right? Effort, number of hours, content, projects, your resume. So can I say that these are the data set which is like which is also going to contribute in terms of making a decision? Agree everyone till this point? Yes. So whatever data that this particular person is having as of now, so can I say that that data set is not a sufficient enough to make a final decision? So there are other data set, but the person doesn't know like to which data set, what kind of a weightage I'm supposed to give. So initially, what this person will do is that what this like person will can do is, so maybe he can give a weightage that okay, so for this input, for this input, for this input, for this input, I will assign a weightage. And initially, I don't know like whether this data set is going to contribute 0.01%, 0.11%, or maybe 100%, right? So initially, we will try to assign a weightage, and weightage is nothing but 1 by n. So that will be a weightage of all this data that we have. So I is nothing but particular instance of the data set. Capital N is nothing but total number of the data that we have. So let's suppose I have 5 record. So in that case, what will be a weightage of all of these 5 records? So can I say that 1 by 5? So that will be a weightage of all of these row records that we have. Agree everyone? So if we have a 5 records, so in that case, weightage of each and every data set will be 1 by 5 over here. Okay, so this is the weightage. Now what we will do is a number of decision maker is equal to 3, let's suppose, right? So we have total number of decision maker is equal to 3. Civil engineer guy, his friend, and his friend of friend. Now what I will do is I'll try to go to a first person. So this civil engineer guy, right? And then this person will try to make a decision. So decision means for sure a model this person is going to build, right? So let's suppose this person is going to make a decision, and he has built some sort of a model, or maybe whatever decision he is making. So for sure that is a model. So step number 1 over here will be, so let's try to make a decision maker. So let's try to build one decision maker, and we can try to denote these things as GM of X. Means we are trying to provide X amount of data, right? To what? To our mth decision maker. So this is the very first decision maker, civil engineering guy, right? So I have provided this data to him, and he is trying to make some sort of a decision. And all this data set comes with the weight. First, weightage of all the data set is completely same. Then what we will do is, so then we will try to step number 2. So we will try to calculate our error. That okay, so this person has made a final decision, right? Maybe yes, no, 1, -1. But what is a error that we have received with respect to all of this data set? Because this data set comes with y, right? So if I'm able to find out the prediction and I have a y, I will get to know, okay, fine, what is the error? So here it will try to calculate an error for this mth decision maker. So this is the decision, means you can say this is nothing but y hat. So I'm able to make a decision. I have built a model. I'm able to make a decision. Now, whatever decision I have made, so I'll try to calculate an error. So error for obviously all the data set, right? So here error will be nothing but it's a summation of I is equal to 1 till n for all the data set, right? So error is nothing but, so weightage of this error and difference of all the input where y is not equal to y hat, or I can say, which is a function of gm of x. So gm of x, I'm trying to say, because y hat is nothing but it's a gm of x. This is how I'm trying to represent these things. So here, divided by, right? So divided by a total number of the data set. So here I'm trying to calculate what? Error. So the way we are calculating an error, everywhere we try to calculate the error, and based on the errors we try to modify, right? That what kind of modifications we can try to do so that I can be a better decision maker. So in the very first point, we have built a model. Let's suppose we have built a decision tree model, okay, or maybe a logistic regression model we have built, just for understanding purpose, I'm telling you. So this is a decision tree model I have built based on this data input with weightage. Now, second step is we will try to find out the error of all the data set, right? So for making all the decision, this is what we have done, even in case of a decision tree, whether it was a classification or a regression. So error is nothing but weightage into a data set, or like differences between where y is not equal to y hat. So this is the meaning of this one. So wherever y is not equal to y hat divided by n. Once we will be able to do that, right, then we will try to calculate a compute, which is called as alpha over here. So just try to understand this part. So this is nothing but, so this alpha is nothing but 1 by 2 logarithmic of 1 minus error for mth decision maker divided by error for mth decision maker. So this is nothing but, this is called as compute, and compute we are trying to calculate based on the error that we have calculated for this one. So this is the decision maker, which is giving me like a y hat as a result. For this one, I'm trying to calculate the error. Now based on that, so we are trying to calculate a compute. Now why we are trying to calculate this compute? What is the meaning of it? I have built a decision maker. I have built like a algorithm, right? I'm able to get a prediction. I'm able to find out a difference between y and y hat. Now, based on that, I'm supposed to modify my base algorithm. This should be the approach. Agree, everyone? So in ideal cases, what will be the approach? So can I say that approach is nothing but build a decision maker, or maybe build a model, find out the error, based on error, tune it. So can I say that this will be an ideal approach, right? But why there is a step number 3? Why we are trying to calculate this alpha, and what is the meaning of this compute, which I'm trying to say, right? Well, I think we are supposed to understand, and then multiple queries will be clarified automatically. So I'm saying that this alpha is going to help you out to decide what is a weightage of each and every data set that we already have in our sample. Now, what is the meaning of it? So can I say that initially I was not aware about any of this data set, that okay, so to data set number 1, 2, 3, 4, or maybe 5, what kind of a weightage I'm supposed to give? Initially, I'm not aware about a contribution of a data set to my final decision. Agree, everyone? Yes. So we are not aware about it in a beginning. So we are not aware about these things in a beginning. So what we have done? So we have assigned an equal weight, but practically it's not possible, right? So some of the data set must be having a high weightage. Some of the data set must be having a low weightage, right? So practically it's not possible to consider a weightage of all the data set as same, just like a civil engineering guy. So if you will ask them, if you'll tell him that, okay, so you will have to build a resume, he will say, yes, I can do it, right? But he don't know how to do it. So if you'll ask him like, okay, fine, so you'll have to build 10 projects, he will say, okay, I will do it maybe. So he will try to resemble those projects, maybe with his construction work or maybe with his civil engineering project. Maybe he is good with that. But here, situation is different. So he was trying to give a same weightage to all the instances or all the data set. But that is not true. And that is the reason he is a weak classifier, because he is not able to, or she is not able to decide a weightage of each and every data set. So can I say that we are supposed to update a weight? We are supposed to update a weightage of each and every records, each and every data set. Agree, everyone? Yes, we are supposed to update it. Now, update it based on what? So based on a instance where my y is not equal to y hat. Yes. So based on the instance where my y is not equal to y hat. So can I say that wherever y is not equal to y hat, so that data set weightage which I have considered is wrong? There is a chance. Agree, everyone? I think all of you are awake, right? Hopefully all of you are not sleeping. Yes. Okay. So can I say that this error term that we are calculating, so we are trying to calculate based on like a weightage into wherever I don't have y is equal to y hat. So how we are calculating error? So we are calculating error for a place, for a particular places where y is not equal to y hat. So here, and based on that, I'm trying to calculate a function called as alpha, which is based out of, which is completely dependent upon the error term. So log of errors. This is what we are trying to like consider, or this is what we are trying to understand over here, right? So the main objective over here is to reassign a weightage. Reassign a weightage of all of these attributes or this data set that we have considered. All of this data set, all of these records that we have considered. Now, so what will be a weight update function? So here we are trying to update a weight for a records, for all the n number of records, wherever y is not equal to y hat. So whatever records which is not participating in terms of making a decision based on that, I'm not able to make a final decision. So I have to update a weight of those data set. So here is a weight update function. So a new weights or weight of I will be nothing but a old weight, right, into exponent of, I would say, alpha of this mth decision maker, the compute of this mth decision maker that we are trying to calculate, into a multiplication of y where y is not equal to y hat. This is a weight update function. So for record number 1, 2, 3, 4, 5, wherever y is not equal to y hat, what I will do is I will try to update a weight. So now it won't be 1 by 5. It will change. So it will try to change. So the very first one is called as a weak classifier. Again, many people are not aware about the actual meaning. It's called as weak classifier because the weight is which is given to this. So whatever data I'm providing to this particular classifier, right, or this decision maker, so weightage of all the data set is same. He's not able to assign a proper weightage to each and every one. So it's kind of a random guessing. And that is called as weak classifier. Weight was given equally to all the samples, right? So this is something. So this is this is how we will try to update our weight. So new weight is nothing but old weight into exponent of bracket alpha m, which we are trying to calculate based out of the error that I will be able to receive. So log error into a data set where y is not equal to y hat. So intersection of y is not equal to y hat. Now, so then fifth step, normalize a new sample weight so that summation of all the weightage will be equal to 1. So can I say that 1 by 5 plus 1 by 5 plus 1 by 5 times is equal to 1? Because we have done 1 by n, right? So again, if you are going to update a weight, but let's suppose your weight update has given maybe 10 to one of the samples, then 20 to another sample, then 100 to another sample. So again, it will be a kind of a problematic, right, for all of us. So what we do is, so we try to control a weight expansion over here. So we are trying to control that. Okay, fine. So you are updating a weight. I don't have any kind of issue, but do one thing. after updation of a weight, let's suppose you have changed these things to 1 by 4, 1 by 6 or something, but after updation of the weight, make sure that summation of all the weights for this 5 data set is equal to what? Is equal to 1. So that is the reason we try to normalize weight to 1. So summation of, or maybe normalize weight. So when I say like a weight to 1, so it's basically a summation of all the weights of all the sample. So we are trying to normalize the weight. Then what we will do? So then we will try to send again this new weight. So now weight is updated. So weight for all of these records are updated now, right? So now what will be a next step? Now I will try to involve. So in a very first place, can I say that it was a civil guy? Now with this updated weight, now my data set is updated, right? All the samples are updated. So now this data I will try to send to whom? I will try to send to a friend of this civil engineer who is doing a preparation. Is it making sense? Or maybe M2 decision maker. So in a next iteration, then again I will try to update a weight. Then I will try to send this data to a guy who is already working into our industry, right? So based on that, we will keep on doing this thing. So let's suppose I have a 10 person in a chain. So I'll keep on updating our weights, and then that updated weight on top of the data set, I'll keep on sending to the person, right? So that is something that we do in terms of a boosting. Now I'll try to show you a slide. So instead of like writing all of these things over here, so it will be better if I can show you our slides, which will help you out even at the time of revision. That's the reason. So we have created this beautiful slide just to help you out even in future. So I think my screen is visible to all of you, right? Yes. Okay. So these are the steps that we have discussed, and let's try to repeat our same steps. And those who are not able to understand, or those who are able to understand 10-20%, so this time let's try to understand these things completely. What happens in boosting? So just remember this name, boost. What is the meaning of boosting? If you are able to understand this, I think problem is solved. You all will be able to answer to this question. Okay. What I told you one by one. So I told you that there are n number of a record I have. There are m number of decision maker I have. I have to make a decision, 1 or -1, yes, no, A or B. Simple, right? Now what I have done is, so let's suppose I have n number of records. So record number 1, record number 2, record number, maybe I can try to draw a bigger picture, 2, 3, 4, and 5. So 1 number record, 2 number record, 3 number record, 4 number record, 5 number record, right? So who will be a weak classifier over here, or who will be a weak decision maker? A decision maker who thinks that all the data set is important, equally important. Yes. So generally what happens when you try to solve a problem from a Kaggle? So what do? So you just try to copy a data set, and then you will start writing some sort of a code, right? First of all for EDA, and you will do EDA, and then you will try to like import some of the models from scikit-learn, and then you will try to build a model. Sometimes you will get 100% accuracy. Sometimes you will get 40% accuracy. When you receive 40% accuracy, you feel frustrated, and when you feel like 100% accuracy, when you get 100% accuracy, you feel like a pro. Yes, I'm able to build a model, and my accuracy is 100%. But is it a correct way? Is it a correct approach? Right? So this is what we feel, right? But we are actually a big decision maker, unless and until I'm not having idea about the complete data set, its functional intuition and everything, right? What we have done over there. So we have given an equal weightage to everything, right? So like, let's do everything over here. So here, the idea is that, okay, so big decision maker means I have 5 number of records, means capital N number of records I have. This is what we have mentioned. Assume that number of training sample is denoted by capital N. Training sample means 5 number of samples I'm trying to use for a training purpose. Okay. Now the number of iteration or created tree is equal to m, means number of decision maker is equal to m. So in our case, let's suppose we are trying to use 3 decision maker, 3 decision tree, 1, 2, 3, right? So let's suppose like a decision tree 1 and decision tree like a true and decision tree 3 over here. We are trying to utilize. So 3 decision maker, so m is equal to 3 over here. So m is equal to 3. Now, so initially, I won't be having any idea about the data set. So what I will do is, so I'll try to assign the equal weightage. So I have 5. So 1 by 5, 1 by 5, 1 by 5, 1 by 5, 1 by 5 to all. This is the weightage of all the data set. Now, so this is what we have mentioned in step number 1, right? Where I is nothing but I is equal to 1 till n. So initial observations, weight Wi is equal to 1 by n. Now for all the samples. So now for m is equal to 1 till m, right? So now for m is equal to 1 to m means decision maker 1 till decision maker 3, right? So in a iteration, let's suppose I'm going through a for loop. So in a very first for loop, what we will do? So decision maker number 1, right? Now we have built one model. First decision tree we have built based on this data set available to me. Weightage is already defined. So this decision maker that we have built, decision tree number 1. So this is a decision tree using a weightage Wi. So whatever initial weight that we have assigned, so based on that, so we are trying to build the model. Now we will try to compute the error. So what is the error? Error is nothing but, so weightage because error. So we'll try to find out y hat for this, y hat for this, y hat for this, y hat for this, y hat for this. So y hat for all of this, we'll try to identify based on this decision maker. So it's just a function of gm of x we have written. You can consider y hat. If you are finding out this things like difficult, so just for you in a simple way, it's a y hat or a final model that we have built, which will give me a final decision. So error computation will be able to do, but my ultimate goal is to update a weight. So I will try to update a weight. How I will try to update a weight? So old weight 1 by 5 that we have given, exponential of alpha of m. What is alpha of m? Which is called as compute function. So compute function is nothing but half of log of 1 minus error divided by error that we have received for a respective decision maker for a particular data set. So where y is not equal to y hat. This is the meaning of this one. Now here, right? So I will be able to compute, and then based on that, so I'll try to update a weight. So now let's suppose for this data set, I have updated a weight for this data set. These two is same. So let's suppose I have updated a weight. So there is a possibility that summation of weight will be 1 or anything else, maybe 100, 200, depends upon my update. So what I will do is I'll try to normalize a new sample weight so that their summation is equal to 1. So we all understand a concept of normalization, right? So we can try to divide, subtract, whatever we want, we can do it, but we have to normalize so that my data set will be in between certain range. Summation of all the weights should always be equal to 1. Now construct a next tree. So now I will come to this one, but this will receive a different data. This will receive a data where we have changed a weightage. Agree everyone? So how the second one will be a better decision maker? So how I'm trying to segregate a weak, then maybe a little bit better and the best. Yes. What is I in weight calculation formula? So it's saying that it's nothing but it's an intersection of y where y is not equal to y hat. So this is what it means. Now at the end, compare the summation of result. Now what will happen? So let's go to this step. So at the end, compare the summation of result from all the tree. So here we have built 3 decision maker. Compare the summation of result from all decision tree, and final result is either the one with the highest sum for a regression, or it is in the classes which is the most voted average for a classifier. So based on that, we will try to make a final decision. So at end, how we are going to make a final decision? So let's suppose we have trained all of these 3 things, 3 decision maker, right, with updated weights. So here, when it will come to making a final decision, so we have clearly mentioned over here that compare the summation of a result from all the tree and final, let's suppose base model is a decision tree, and the final result is either the one with the highest summation for a regression problem or a class which is having a most weighted vote. Formula wise, so it's clearly mentioned over here, if you will try to understand this one. So output in case of a regression is going to be argmax of decision maker, summation of what? So summation of decision maker 1 till 3. Let's suppose we have 3 decision maker into its compute function. So for all the individual decision maker, we are trying to calculate a compute function based on what? Based on error. So it is nothing but summation of, so argmax of summation of alpha m compute function into a decision that it is going to deliver. So this will be a final decision. So argmax of that. In case of a classification, right? So we try to calculate what? So we try to calculate a sigmoid of the same thing so that I will be able to give you the final classes. So this is what happens in case of a basic boosting algorithm, and the name of this algorithm that we were trying to discuss is called as ADA boost or adaptive boosting. So it will keep on adopting like a previous weights, and then it will try to boost itself each and every time it is trying to boost itself. So this is something called as ADA boost, one of the algorithm from a boosting concept. So is this things clear to everyone? Means weight are transferred to the next model. Yes, the updated weight. So new model will be trained on the updated weight based on the error and based on the compute that we have received from the previous one. Yes. We'll sum up all the results for the regression. So it's a argmax. Now, so forget about this one. So I'll come to this discussion. That is completely fine. But I would like to show you something over here, right? Whatever we have discussed. So just to understand those things in a practical way. Yes. So just try to look into this picture and try to understand and just try to correlate with this mathematical discussion. So can I say we have a multiple records over here? Agree? Everyone? Yes. Okay. Now, here in our record, we have column number A, B, and C. This is the data set that we have, column A, B, and C. Column D is nothing but it's my label data set. A, B, C is nothing but it's a feature, and D is nothing but label. What is the total number of record that we have? 8. So what will be the initial weight I will try to assign to all the records? 1/8. So can I say that we have created a column E for explanation, right? So where weight of all the records is equal to 1/8. Agree everyone? Yes. Okay, fine. So this is completely fine. So we will we all will agree with that one. Okay. Now here, right here, what we are trying to do is, so let's suppose I'm trying to use a decision tree, right? So we have a multiple models. So decision tree number 1, 2, 3, 4, and maybe in this way. Okay. So here, what we are trying to do is, so maybe we can try to calculate Gini indexing. We can try to, so if we have to build a decision tree, and if I will give you this data set, A, B, C, and D, so A, B, C is nothing but your feature column, and D is nothing but your label column, right? And then if I'll ask you, so can you please try to build a decision tree? So is it possible to build a decision tree? Yes. Yeah, it is possible. We all are aware about it, and we all have studied that. Yes, decision tree, how we can try to build a decision tree. It's very, very easy for all of us. And that too in a like a categorical data set, it's actually very, very easy for all of us. So we all are aware about Gini indexing or Gini impurity or information loss. Okay. So here, there is a possibility that chest pain can be apparent, or maybe like a artery blockage can be apparent, or maybe weight of the person can be apparent. Right, that is possible. So weight of the person, arterial block, chest pain. So these are the 3 separations or 3 tree that we have calculated. Now we are here trying to calculate a Gini indexing for a chest pain, Gini indexing for artery blockage, and Gini indexing for a body weight. So now these are the Gini indexing for all of these three columns. So you can try to do a calculation manually. So you will be able to find out the same result even over here. Now, which column we are supposed to select for a parent? Okay, so which column? Body weight, artery, or maybe a chest pain? Can I say that with a least Gini indexing, we are supposed to make a decision, right? I think we all are aware about Gini impurity. So impurity should be less. So in this case, my vote will go for what? So my vote will go for maybe a body weight, right? So maybe I can try to use this one. So where body weight is, so threshold is 176. So body weight is this one. Now I have decided a threshold. So body weight is a parent node. Threshold 176. Let's suppose I have kept. So lesser than and greater than. And this way I have divided. Okay, that is completely fine. Now, so this is a decision maker that we have built. Now this is your G of X. Is it fine? This is a model you have finalized, right? So this is a model which will give you a prediction or Y hat. Agree or disagree, guys? Don't feel like asleep. So yeah, so this is a model that we can try to use. Okay. Now we will calculate the contribution of this tree or stumps to our final decision using the formula. So contribution of this one is nothing but 1 by 2 log of 1 minus error. So that's nothing but compute alpha. We are trying to calculate. So 1 by 2 log of 1 minus error divided by error. So as the system classified only one data incorrectly out of the 8 data, so hence a total error is equal to 1 by 8. So here we are trying to calculate that what is the total error. So out of 8 data, so it is able to like classify only one data incorrectly, right? So let's suppose error is equal to 1 by 8. So if we will try to put up this 1 by 8 error inside this one, so I will be able to get maybe 0.97. Now based on this 0.97, so we are supposed to do a calculation for a new weight, right? So based on this compute, so we are supposed to do a calculation for the new weightage of each and every one. So here, right? So here, what we will do is, so we will try to update only a weight for that record, only a weight for that particular record. So here is our original record that we have. So yes, 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 4 yes and 4 no. So here, again, let's suppose out of 8 like a record, it is not able to give me an answer correctly for one of the record. So what I will do is, so I need to change a weight. So I have to update a weight. So what is the weight update formula? So can I say that weight update formula is nothing but old weight into exponent of contribution, right? So exponent of might be a alpha m, where I is not equal to, or sorry, y is not equal to y hat. Agree, everyone? So what will be a new weight? So the new weight for someone which has not been classified correctly is equal to 0.33. So previous weight was 1 by 8, 1 by 8, 1 by 8. So what is the value of 1 by 8, by the way? Yes. So 1 by 1.25. So what we will do is, so we are trying to update a weight. So we are trying to like increase the weightage of, so we are trying to increase the weightage of maybe a decision or maybe like a data set which I'm not able to classify correctly. And at the same point of a time, so we are trying to decrease a weight. Here a statement is a little bit like misleading, right? So I'll try to rectify it, but just try to look into the formula. So here what we are doing is, so we are trying to increase the weightage of a thing which was like a which I was not able to classify. So I have to give a more weightage. So let's suppose some of the topic, if you're not able to understand, so what do you do? So can I say that you used to give a more weightage to that topic because you know that topic is important? So people will ask a question on that. So can I say that I'll try to give a more weightage to a topic which I will not be able to understand, yes, same is applicable over here. So we are trying to increase a weightage of that particular instance which we were not able to classify. So we are trying to use plus, and here we are trying to use minus. Same formula is same. Okay, so here so yeah, जिसमें fail हुए उसमें ज़्यादा पढ़ना पड़ता है, right? Then only you will be able to clear. So this is what we are trying to do. So we are trying to increase it and we are trying to decrease it. So we are trying to increase the weightage of those which I was not able to understand, and I was trying to decrease the weightage of those which I was able to understand, because yeah, I have already adopted the previous one, right? Okay, so we will try to do that, and then we are trying to normalize a sample weight. So if we add all the new sample weight, we get 0.68. Hence, for normalization, we divide a sample weight by 0.68. So we are trying to divide all of these weightages by the summation of the whole weight, right? So here we are trying to normalize it, right? So we are trying to normalize it, and then we create a normalized sample weight as shown below. So this is the normalized sample weight that we are trying to create. This was the step, next step, right? Now this new normalized weight with this data set will be considered as a sample weight for the next iteration. So along with this normalized weight, so weightage of now all of this algorithm will change, and then this data set will be considered for the next model. So then we create a new tree which considered the data set which was prepared using a new sample weight. So now this sample weight won't be used. So we are not going to use this sample weight at all. We are going to use this sample weight where we have made some sort of a update, a data set which I was not able to understand, right? So suppose entry or stumps that we have are classified a person as a heart patient, and entry or stumps are classifying person as a healthy one, then contribution of M and N trees are added separately. Whichever has the higher value, a person is classified as that. So let's suppose based on that, so we'll try to make a decision. So this is how this ADA boost algorithm works with respect to a data set. So is this clear? Normalize कैसे कर रहे हैं? Okay, see what we are doing is that we are trying to find out the summation of all of this. Summation of all of this is equal to 0.68. Now 0.5 divided by 0.68, what will be the result? Yeah, so this by 0.68, 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 this by 0.68. So this is how we are normalizing, and this is what we have mentioned. Okay, so just try to understand in this way. Okay, so this is a neat and clear concept that you are supposed to understand in terms of adaptive boosting or ADA boost. So this is how adaptive boosting happens at any point of a time. So do we apply regulation later? See, if you are using a decision tree, so by default, decision tree applies a normalization. By doing what? By doing a pruning, post pruning or pre pruning, right? So that I will be able to control what? Error. Because regulation is a technique which controls your final error. And that is the same concept we are trying to implement even over here. What is stumps in boosting? A stumps is nothing but I'm saying decision tree 1, 2, 3. So it simply means that 3 stumps we have. So one decision tree. A stumps is just a name, nothing else. So just like a technical name. So it's called it simply means that it's a tree I'm trying to refer. So how many of you are able to understand this algorithm, adaptive boosting, or a meaning of boosting? Because our next algorithm which I'm going to discuss will be related to this one. See, we just talked about a decision tree, but our bagging approach is related to a tree, boosting approach related to a tree, right? So we are like trying to utilize a same concept again and again and again. Okay, so understood, 80%. Yes, sir, 99%. I don't know how you evaluate 99%. Got it. Okay, understood. Boosting greater than understood, needs some revision. This note is nice. Yeah, all of our notes are actually very nice. So in a last phase, right? So when you will go for a revision, I'll provide you like a bundle of all the notes, right? Where examples, definitions, implementations, basic implementations, everything you will be able to find out. And I believe it's already available inside your dashboard since the very first day for all the algorithms, right? So it's actually very good. So once you are able to understand point by point everything, then second time when you will go for a revision, it will not even take more than 5 minutes of time to go through one algorithm. Will boosting we only use descent tree? Yes. Again, inside that there are multiple algorithms. आज के लिए काफी हो गया. Okay. Why there is one time value is 0.33 in a new sample weight. Okay, this is what I think I was trying to explain. This is how we are trying to do a calculation, right? So we are trying to calculate a new weight for those data where I was not able to classify properly, where I was getting an error. So I'll try to update what? Like I've given an example, right? So let's suppose if you are not able to understand some topic, what you will do? You will try to give more weightage, right? So we are trying to do plus over there. And then for rest of the things, you have to decrease the weightage. Is the same 1 by n for the large number of the record as well as, yes, yeah, it's the same. Where to increase or decrease the sample weights? Here we are increasing and decreasing, right? So here we are trying to add. So actually this statement in this notebook, so I'm supposed to add plus sign over here, put up the plus sign over here. Notes are enough, need to revise, understood, but need practice. Yeah, just one time, I believe. So if you are able to understand the core concept, and then if you are going through it, I believe it will help you out a lot, and you will never be able to forget. When this video will be available, tonight itself, it will be available. Observation same ही रहता है या weight update करने के बाद change होगा? See, actual observation is same, actual data set is same, but along with the weightage, now we are sending a data set, right? So for sure that data set, actual result or actual input will change. But revise करना पड़ेगा, इससे हो जाएगा. Okay, great. Need more hands-on, get more clarity, sir. Yeah, you will be able to get a hands-on on everything, right? Whatever I'm discussing over here, and that too in very, very detail, plus a task. All those things will be there, but theory and mathematics is equally important, right? Hands-on, anyhow, we are not going to leave like anything in our hands-on. We are adding a new features, kind of opposite of a dimensional reduction. No, it's not like we are adding a new feature. See, defining a weightage simply means that we are trying to just say that, okay, fine. So if this is one record value and this one record will be considered completely for a decision making, instead of that, I'm saying that no, 0.7% of that records or 0.7% of the contribution will be taken from this particular record. This is what we are trying to say. This is the meaning of a weightage. Normalized weight के बाद का बताइए, बता तो दिए यार और क्या. Normalized after like normalizing a weight, so then it will go to a next decision maker, decision tree 2, then 3, then 4. That's the reason. So repeatedly I'm giving you example, civil engineer wala, and then like after civil engineer, so his friend and then his friend. Whose weight we decrease then? For a data set which we were able to classify correctly. So for those, we decrease our weight. I've already told you everything. Don't worry. So when you will go through this one, so I think you will get to know about it. आप ही बता दो क्या बताना है. How much more weight we increase and how will decide it? Okay, I think this is a formula that we have discussed. Weight into a compute for all those instances where I is not equal to or y is not equal to y hat, and exact same thing we are doing over here. Is class over? Yes, for today it's over. Yeah. Please upload a notebook. Yeah, this will be available. Don't worry. It's already available inside your dashboard. If you have checked your dashboard, so in your previous class recordings, these things are available actually since the very first day. Since the last 6-7 months, it's available. Unable to see in a dashboard. See, other people are able to find it out. Means it's available, right? Because number of sections are like very long in our cases. That's the reason. So even for us, it's tough to maintain everything inside your dashboard, unless and until we are not releasing a new dashboard, which we are going to release very, very soon now. So yeah, we are giving you previous class recording, your class recording, previous class notes, your class notes, then assignment. So it's like, it's difficult to maintain in one single portal, even for us. The sigmoid is taken for the classification, is it? Yes, Saroj. Yeah, that's true. So if data set has 1 lakh row, the initial weight will be extremely low. Exactly, that's true. The ADA boosting weak learners hai, good learners ho jayenge. Yeah, that's great. Please tell once how you split using one column weight of the how you split by using one column weight. Not able to get your question, by the way. Is in backward propagation also we just adjust the weight here also? No. So don't try to compare this with the backward propagation, because tomorrow I'm going to talk about something called as gradient boosting. So here a concept of backward propagation is applicable in case of a gradient boosting, right? So let's join tomorrow's class, and then like I'll tell you so how this backward propagation approach, not exactly a backward propagation, it's not a correct word so over here in this context at least. So I'll be talking about this gradient boosting. So adaptive boosting is something that we have understood, then gradient boosting, and then we'll be talking about our next one, and the final one in a boosting is called as XGBoost. So I'll be talking about these functions, and this functions looks a little bit scary, but it's easy to understand. Believe me, it's very easy to understand these functions. How to decide a number of decision tree? It's a hyperparameter, so you can't decide. You will do a cross validation, and then you will be able to tune it. राइट प्रिडिक्शन का वेट रिड्यूस करेंगे तो उसके बाद मॉडल पर नेगेटिव इंपैक्ट नहीं होगा क्या? No, so because see what we believe is like if there is some data set which we are able to understand, so even we are going to decrease the weightage of it, it's completely fine. How you memorize all the question? I'm taking classes in last 5 years, right? So big data and data science and all those tech stacks, so it's like kind of a regular job for me. Repetitions, right? Just because of repetition you can say. राइट प्रेडिक्शन की जो रिड्यूस करेंगे तो उसको मॉडल पे नेगेटिव इम्पैक्ट. ओके, आई थिंक आई हैव ऑलरेडी आंसर. You are comparing with the Kegel practice when we get 90%, will be happy. What do you think we are missing there? Why should not happy when we get 90%? You should not feel happy because what I feel is like you are trying to build a model without understanding proper business use cases and a data set attributes relationship in between. Plus, when you are trying to build a model, so you're not trying to implement maybe a retraining approach over there. You are not trying to create maybe some sort of a pipeline. What will happen tomorrow when new data set will come? So is your model, are you going to give me an assurity that your model is going to behave in the similar way with unknown data set? Then what your model should do? If not, right? So that is the reason. So I was like giving you that example, I believe. ये सारे फॉर्मूले याद रखने पड़ेंगे. Actually, you are not supposed to remember it. Just go through it once or twice and try to recall in your brain. Don't write, recall it, right? Automatically you will be able to understand. Major factor for that is a domain knowledge. Yeah, see, data science, like not a domain knowledge, I will say. See, if I'm a technical person, right, so I can't get a domain expertise in all the domains, all the hundreds of domains, right? That's the reason. So in your team there will be a functional member, and there will be a people from a client side who will try to discuss their business problem plus a data set plus attribute plus a sources plus a relations plus third party data impact. So as a data scientist, what we have to do is we have to understand that factors first of all. It's not like we'll start writing a code, right? That okay, fine, so let's do a ED and let's build a model. No, we should not do that actually. So domain knowledge is not important. When we say domain knowledge means you're actually talking about a pure functional person, right, who is working in that domain since a very long time. No, you're not supposed to get a domain knowledge, but data understanding. There is a difference between these two. I have a question on logistic regression. How to build ROC curve for a multi-class logistic regression? Okay. So for building a ROC curve, we were trying to use a true negative and like a false positive. This is something that we were trying to use. So you have to like build confusion matrices for a multi-class classification, which many of you have already done it in your task. And out of that, so yes, you will be with for a different threshold. Just try to find out. That's a way. Interview formula पूछते हैं, no one will ask formula, but the thing is, let's suppose I'm trying to explain, right? So if I'll give you explanation in this way, that okay, fine, so XGBoost, there will be like a multiple decision maker. One will try to boost others, and then other will be a better decision maker. So will you like this? Would you like this kind of a discussion? No, right? So you're not going to accept that kind of a discussions. So I'm talking about what? Theoretical concept, first of all, trying to relate those things with some like layman examples, and then mathematics, then maybe with some data set, proof of that mathematics, then implementation, then deployment. So in this way, you all will be able to understand. So when you are going for an interview, so if you have to prove yourself, if you will try to prove yourself in this way, everyone will accept that, okay, fine, so this is a person who knows about each and everything end to end, and this person is able to answer. So that is the reason. So it's not mandatory to remember, or no one remembers this formula, believe me, no one remembers this formula, but it's good to explain anything with a context as well as with some reality, right? Not 100%, maybe 50%, so that will work for you. One humble request from my side: when you go for creating a model, please implement logging module. I'm confused where and who implement logging modules. Only one model. After that, I will do myself. No issue. So from next week onwards, discussions with your batchmates is going to start, right? So where your batchmate will present a work that they have done. And believe me, most of 90% plus submissions which I have received, right? They have implemented a modular coding. They have done this logging. Each and everything is implemented. So I think after Monday, so back to back, as this discussion will progress, you will see these things in a multiple places. So I think in this way, you will be having a code, a discussion, explanation, implementation, everything. So your issue will be resolved. Depender. I got an interview question. Why do we use a log in some of the machine learning algorithm? Good to know. Just wanted to share. So see, log, it's not like we are using log everywhere, right? We are using sigmoid. We are using like a log. We are using a hypertangent as well. So it's not like we are using log everywhere. No, it's not true. So let's suppose I'm talking about a softness function. So where is a log? It's exponent that we are using, right? If I'm talking about the softness function, if I'm talking about the sigmoid function, so again exponent we are using over there. So just to observe again, if it is like a random question, in that case, if I have to answer, if I have to give some answer, then what I will say is that in case of exponent or in case of logs, so as things will increase, so as maybe one of the data set or one of the axis will try to increase itself, in that case other will try to, or other axis will try to adjust itself in a smoothest possible way. Means there will be a consistent changes you will be able to see, which is required. When one is moving, other should also move. So maybe in that case, log is important. Please increase the deadline for DVC task. See, it's already been 2 weeks. You can submit your task even after 2 weeks. I don't have any issue. We'll evaluate and we'll check your solution. So I'm yet to evaluate and some of your tasks. Right, we'll do that. But there is a reward which I have attached with this task, right? So I told you that those who are going to submit it before within this 2 week, right? So all of you are going to get AI Ops batch access from my side. So it's not like I will not evaluate. The only thing is you will not be able to get a reward. But still, just try this out. Yeah. Working explain करने तो सही रहेगा. Working explain of what? The layman example used by you are unique and very easy to understand, and there's not found anywhere else. Yeah, because I used to like it's natural, right? So it's So see, if you'll watch my other classes, right? So in other class XGBoost, when I have explained, I have given some other layman examples. So that happens. So if you are going through my previous 10 different class recordings and lecture, I think one of the class recordings is available. You will end up getting maybe 10 different context and example. I have submitted yesterday. Yeah, there is deadline is till tomorrow. So till tomorrow, you all can submit. I don't have any issue. 2 week, I told you, right? So 2 week is going to end by tomorrow. Okay, the pros and cons of using one algo over other needs to be understood very deeply. Yes, and that you will be able to understand when you will do a practical implementation, back to back, and then comparison. That okay, fine. So this is one, then this is another. So that is the best way. We are not able to understand how y is not equal to c. This is like a very simple. So wherever y is not matching with the y hat. So for that instance, we will try to change something. This is the meaning of that, Murli. Okay, so fine, guys. I think I am able to answer all of your questions, and we are good. When Big Data Fast Track is available in a dashboard, first of all, complete your computer vision and NLP. Those syllabus itself is very huge. Even if you'll start today, so it will take a huge amount of time. Even processes are very heavy over there, right? So go in a step-by-step manner. Big data classes are already going on, so if you want, we can dump those recordings by tomorrow itself, right? In a beginning, we were not having a big data recording. I had a big data recording since my like a 2 year back recording was there. Uh, but now we have a latest recording as well, because all of you are aware about this, right? So there is a separate big data batches that we are running. So I can dump those recordings and materials. And that is from a Saurav Agarwal. So Saurav is working with NVIDIA as an architect. So he's like taking that class. I have a cover till hopes from a recorded session. Hope to cover a previous things as soon as possible so that I can get part of the class. Yeah, for sure. No, yes. Yes, Mohit. So please, I'm really very sorry. So Mohit, guys, Mohit will try to share his experience. So yes, Mohit, please.
Yes, sir. Mohit said.
First of all, congratulations, Mohit.
Thank you, sir.
You can talk about your like experience. What is the interview pattern and all those things? I think it will be helpful for all of us.
Yeah, basically it's regarding as a business analyst, not as a data scientist, because my current profile, I'm working as a business analyst. So yeah, regarding this, it's like as a business analyst, but having a knowledge of Python and machine learning tools and algorithm, all those make me a separate candidate for them to choose me. Means like, and also like they are looking for the person for like as a person for the Mastercards. And I also have a background working with NBFCs, like non-banking financial company. So that's why they prefer me, and like interview is quite good. They asked me a few questions about Python as well as few questions on machine learning. But they said, okay, we just testing our knowledge, but actual work is not like this. The actual work is they saying about like we have to extract the data from the SQL and AWS clouds, and like transform them using the Alteryx as a tool, and they have a visualization tool. They said we will train you about that thing. So this is all about the interview, and yeah, they give me the offer. But before joining, just I want to like talk to one, like, okay, should I join that or not, because I'm preparing for the data scientist. That's why.
Okay, so yeah, Mohit, what I feel is like you should join, and maybe uh, we can connect for that one, right? So what I feel is like yes, you should join, and let me just ping you my. Okay, so I'm a part of this group, so you can join, and then we can have a discussion. And yes, you should join. So maybe in like a next 9 months, 10 months, or 1 year, you can try to make another transition, which will be like a pretty much possible. But yeah, and again inside like a Wipro, so you will be able to see multiple different verticals. So whenever you would like to like switch from one verticals to other verticals, that is also possible. Just depends upon your dependencies in your current project and like your managers, but it is possible to like switch from one verticals to another verticals. Yeah.
Okay. Okay. Thank you, sir.
Yeah, so I'm just like pinging you this link so you can join, and I'm part of this group. So even Chris is a part of this group, so we all can, if you want, so we can have a
Yeah.
discussion. Just ping
Yes.
you this link in your chat.
Okay, sir. Yes, sir.
Yeah, thanks.
Thank you, sir.
Yeah, thank you. Okay, so fine, guys. I think we are good, right? So we are good for today. So thank you so much. Hope you all have enjoyed this lecture. You all are able to learn something, at least maybe 10-20%. Yeah. So we'll try to continue with the same lecture tomorrow, and we'll try to add a few more topics on top of the same thing, and then back to back implementation. Yeah. With that, thank you so much. Revision is important. Whatever task I'm giving you, that is important. There is a certain perspective I have. That's the reason I'm giving you a task back to back, right? So that it will help you out a lot. And regarding this DVC task, so yes, tomorrow is the deadline. You all can submit, those who are like working on that. Plus, from next week onwards, so we are going to start your internal discussion. So we will not discuss, I'll not discuss, my team will not discuss anything. You guys can discuss like whatever task, whatever things that you have created, right? So all of your work you can discuss with each other, and you can share a knowledge with each other. What I want you is like you have to work on your presentation skill. Plus, you should know. So, what is a point where maybe you will get rejected, or maybe you will not be able to explain those things. So, when you will explain your work, I think you all will be able to figure it out. That okay, fine. So, what is a blockage, and then you will be able to improvise even those areas. That's the reason. So we are keeping this discussion. So try to participate as much as possible in this discussion. If one person has already discussed their solution, it's not like you can't discuss same thing. You are free to discuss anything you want, right? Anything means from a task, whatever task I have assigned to you, and whatever solution that you have prepared. So you should discuss those solution, those tasks in very detail. So if you are taking half an hour, 1 hour, no issue. But the whole idea is to talk about your work over there. Very simple. Yeah. With that, thank you so much, and see you again in my tomorrow's class. Thank you. Have a great day, night ahead.